Hello, today we are going to learn Qt QML, Qt Quick, Qt Declarative by following the tutorial from KDAB Introduction to Qt QML, which is a 54-part series so far. For this first, so what is Qt QML, Qt Quick, Qt Declarative? So it's part of the Qt framework, which is a toolkit for the C++ programming language that allows to create cross-platform graphical user interface applications and other type of applications such as server, multi-threaded, command line, etc. applications that can be cross-platform in the sense that they will run on Linux, Windows, Mac OS on the desktop, Android, and iOS on smartphones, other embedded operating systems and hardware. And Qt Quick, which together with the programming language Qt modeling language QML, which is a user interface markup language, a declarative one, allows to create desktop type applications, but also applications that are made for smartphones with smartphone specific user experience such as swiping and animations and transitions and other types of UI rich in the designer sense applications such as in-car infotainment systems, on the plane, those entertainment systems that you get at your seat, etc. Okay, so in order to follow the tutorial introduction to Qt QML from KDAB, we will need a Linux virtual machine, and inside we will install Qt Creator, which is the integrated development environment from the Qt framework. So let's go there. I'm going to try to use the upcoming version of Kubuntu for that. 2304. Okay, desktop image, 64-bit PC AMD 64 desktop image sounds okay. The date is today. Save image. While it's downloading, let's prepare the Virt Manager, virtualization software. Let's make some room. Okay, so back to QML, Qt Quick, Qt Declarative. So we have originally developed by Nokia as part of the Qt framework. Was thought to be a framework and programming language for smartphones with touch input, infinite scrolling, fluid animations, user experience, 60 FPS, a fast way for designers to edit and then send to the phone, so no compilation steps, business logic written in JavaScript, the UI described in a programming language similar to JSON, and we have the ISO for Ubuntu 23.04 downloaded. Let's create a virtual machine. local ISO, browse this guy, lunar desktop, this, refresh, yes, choose volume, forward 10 gigabytes of RAM, and let's make this 15. To 50. Ubuntu 2304. Would you like to start the virtual network default? Yes. BIOS Q35. CPUs, one socket, 15 cores, 15 threads, 10 gigabytes of RAM. The hard disk is VirtIO. The CD-ROM is SATA. The network interface card is VirtIO. That's it. Begin installation. Okay, try on reinstall. Okay, so this is a daily build. I'm not sure how stable it is. Hopefully we can install the operating system. Install English US, minimal, no updates, no third party. Guided use entire disk, correct. ESP, ext4. Okay. New York, where are you? Continue. Administrator. Shortest possible password. Ubuntu 2304. Okay, let's pause for a second. Or let's look at QML some more. So you can have JavaScript inline, where you define the bindings or events, or you can include the JavaScript files with extension JS. You can pass objects from the C++ world to the QML world, so from a C++ file to a QML file. It uses the Qt enhancements to C++, so Qt meta object information, the C++ introspection support, so Qt style enums, Qt style properties, Qt style objects, Qt style signals and slots. Okay, so the QML programming language it says that they started by using the JavaScript engine in Chromium, which is called V8, and then they switched to their custom built JavaScript engine. Qt Quick is a suite of C++ objects which are backing the types that you use in files with the extension QML. So item, rectangle, etc. are actually defined in C++ and in Qt Quick. 2D scene graph. Okay. The module is still called Qt Declarative, the module that provides the QML engine and interpreter, the QML parser, which generates QML cache. So takes a file with extension QML and parses it and creates a local cache such that the next time when you need that file with extension QML, you don't need to parse it again. There's this not yet released Qt Quick compiler which converts from QML and JavaScript to C++ in order to be able to compile it natively. So QML Qt Quick, Qt 4.7 and the IDE Qt Creator 2.1. Supports the Symbian operating system, Mimo operating system, Migo operating system. And Ubuntu Touch, operating system for mobile phones from Ubuntu, from Canonical. There's the executables QML scene and QML. You can write business logic either in JavaScript or in C++, and KDAB in their tutorial stress that you should write your business logic in C++, not in JavaScript. Qt Quick controls is so Qt Quick is about rectangles, shapes, colors, transitions, etc. Whereas Qt Quick controls is about desktop components for Qt Quick. So menus, pop-up menus, tool windows, docks, tab bars, buttons, checkboxes, this type of things. There's also Qt Quick Web Engine. Okay. Let's see where we are with the virtual machine. Testing. So installation is complete. You need to restart your computer. Restart now. Remove the installation medium, then press enter. Okay, so the installation seems to have been successful. We added the desktop manager, which is called SDDM Simple Desktop Manager. Okay, let me get a text file about a virtual machine. So the data about the virtual machine is like this: IP address, okay. Let's do some changes in the virtual machine to make them more suitable for me. So configure where are you? Enter edit mode, drag to move, close the editor, unpin Dolphin, unpin the App Store, which is called Plasma Discover, unpin system settings. We have Firefox, Mozilla Firefox. Let's do some things in the console. So the user that has been created during the installer of Ubuntu 23.04 is named administrator, is part of the sudoers, so can become super user by using sudo space su, which I just did. Now I'm going to see what's the state of the apt package manager. So apt update, apt upgrade, apt auto remove. The ISO was from yesterday. Still, there are more than 10 deb packages that can be upgraded, so let's do that. Install the minimum minimorum things such that I can connect using SSH. Okay, so for that we want the SSH server, which is called OpenSSH-server deb file in Debian-based operating systems. And that's about it. I'll reboot and try to not use the IPXE. What is that? Okay, let's try not to use the virtualization software, which is called Virt Manager, Virtual Machine Manager, and instead connect using SSH. So SSH administrator at this thing, Ctrl-Shift-V, yes, password, and I am in the virtual machine. I'm a super user, and install the minimum list of the packages such that I can survive at the command line. So we have bash. Let's install a text editor, Orthodox File Manager, Midnight Commander. Yes. Yes. Unfortunately, probably Emacs needs a empty mail transfer agent in Debian, which in this case is postfix. General mail configuration type. Mail is sent and received directly using SMTP. No. The only delivered mail is the mail for local users. There is no network. Let's do that. Okay. So we need to make sure that the name of the machine is actually Kubuntu 2304. So that's host name CTL. So it's okay, Kubuntu 2304. IP addresses. There's just one network interface card. It's called ENP1S0. Correct IPv4 address 192.168.122.203. Let's disable IPv4, IPv6. Okay, this guy. etc default grub emacs slash etc default grub. I need to modify both grub command line Linux default and grub command line Linux. Okay. The same thing, IPv6.disable equals 1. Access, xc, this thing. Okay, that's it. Default timeout style 0 and timeout 0. Okay, what do I need to do next? Let's install some GUI software. Crusader, the Orthodox file manager, Meld, the alternative to WinMerge. What else do I need? Nothing else comes to mind, so these two. Okay, let's install an RDP server. RDP is the Windows specific remote desktop protocol. So this thing. Okay, and then a command line such as this one. Ctrl-Shift-T. Let's try to connect graphically, not so we've connected console mode style using SSH. And now we're trying to connect GUI style, graphical user interface style, using the RDP protocol. So command line such as this. Copy, Ctrl-V. And we need a different IP address, 203. Okay. We do want this. Okay. Let's not have sound for now. Okay. Login failed. Okay, the wrong username. Let's save this file. Where are you? Zero 0408, today's date. And a random file name. Cancel. So now we can connect via the RDP protocol. Let's continue a bit terraforming the system. So let's configure the Orthodox File Manager Crusader. Layout compact. Make fonts smaller. Make everything as small as possible. Show hidden files. Tab position top. No colors, no general viewer. So we continue using the internal Crusader viewer for F3 keyboard key, but for the F4 keyboard key, the editor will prefer the text editor from the KDE community, which is USR in KDE kit. Okay, Nothing in here, nothing in here, nothing in here, nothing in here. Oh, fonts. Let's make this smaller. And that's it. Okay, let's remove some of the Chrome to make more room for the content. Main toolbar, job toolbar, actions toolbar, FN keys, and show embedded terminal. The tabs should have been at the top. Let's restart Crusader. And now they're at the top, okay? I'll pin Crusader to the task manager, which is the application launcher. So on the first position I have Firefox, on the second I have the file manager, Crusader. Okay, that's it. And from now on I'm connecting to the virtual machine using FreeRDP, using the RDP protocol. And I'll do the screen recording just inside the window of the FreeRDP client. So I'll be back in a second. Okay, so now I'm connected to the virtual machine using the client XFreeRDP, and I'm doing a screen recording that contains just the interior of the FreeRDP window, nothing else. Okay, so let's connect. Okay, so the resolution is correct, the one that I use for screen recordings, which is 1080p. Let's do a bit more of terraforming, of configuring the virtual machine to my liking. So I want the fonts to use as much hinting as possible. I want the fonts to be smaller. Okay, let's make this a bit bigger then. Okay, and then edge, screen edges. I do not want this action, and make this 15%. Why? So 15% because I want quarter tiling. So when I move a window to one edge of the screen, it takes 25% of my screen, so like this. But when I touch in here the right edge, I want it actually to use 50% of the screen. So in here I want 25% of the screen, and in here I want 50% of the screen. So this is similar to what Windows does. As often as possible I want 50%, and when I really want 25%, then I'm actually hitting for the edge, not for the margin. Okay, so that's done. Next, I need the IDE for the QML tutorial. So that's called Qt Creator. Let's make the mouse cursor bigger. Okay, so the RDP client chops parts of the mouse cursor, but that's it. Okay, so in order to install the integrated development environment Qt Creator, I'll need to use the web browser. Let's configure the web browser. So I don't want empty spaces. I do not use Pocket, Head, and toolbars, I do not want to see the bookmarks. So bookmarks toolbar never show. Done. And then I do not want any smarts from Firefox. And settings, I want to be asked where to download files each and every time. And I do not want to see interesting web pages when I open new tabs. So I want a blank page for home page, new windows, and new tabs. And that's it. I'm using Firefox Incognito for everything, but when I need to enter a inside of a web account, then I'm not using Firefox Incognito. And this is the case now. Okay, so this is the integrated development environment, Qt Creator. I will need to download more than Qt Creator. I'll need to also download the Qt framework and Qt declarative module and the sample and the integration with QML for Qt Creator. So let's do that. So Qt.io is the website for the Qt framework. Qt.io. Okay, I need to log in. How do I do that? Okay, I have an account for Qt.io, which is my email address. Copy paste works via FreeRDP. Save. Okay, so I want not Qt commercial, but Qt open source. So this thing. Okay, they make me jump through hoops. I'm actually looking for the Qt binaries. Download the Qt online installer. Yes, I'm on Linux. Linux 64-bit. Online installer, correct. Let's also do what I do on my regular machines. So in the home directory, I make a directory named work. Work daily quarter and day. Okay, so it finished downloading. Let's move the file. Okay. So I'm moving the file using the F, the function keys on my keyboard, so F6 to move. Enter. Okay, let's look at what this file actually is. F3, so it's a file that starts with ELF, so it's a Linux binary, probably using glibc. Yeah, we can see it in here, it uses glibc. So if we make it executable, permissions is executable, and then we can double click on it. Okay, again, I need the online account for Qt.io. Again, copy paste works from my hardware host machine to my virtual machine. Next, I have read no business because I'm an individual. Next, welcome to open source Qt setup. Next. So this downloads the list of packages available. So there's a package manager, there's a list of packages, metadata about packages. It suggests that I install into tilde/qt with an uppercase Q, which is okay with me. I want a custom installation. Okay, what do I want in here? I do not want preview. So what's pre-selected? The IDE under Qt Developer and Designer Tools, it says Qt Creator 10. So I totally want that. CMake Ninja. I'm not sure about this OpenSSL thing. Due to import restrictions. I'm not sure what to do with this, so let's check both. Qt installer framework for creating MSIs on Windows. I do not want this thing. Qt Creator plugin development. I'm not going to develop plugins for the integrated development environment. No debug symbols for the integrated development environment. Qt Design Studio. I have never used this thing. Embedded Linux devices, desktop, Android, previewing, creating animated UI. I'm not sure, okay. And I'm going for the latest and greatest Qt version that was just released, Qt 6.5.0. Okay. So click on it and uncheck all of the extra things. So no Android, no 3D things, no WebAssembly. Qt Quick Timeline. Additional libraries, no 3D. Protobuf. .3D physics. So I want web engine, web view, web sockets, web channel, virtual keyboard, state machine, speech, serials, sensors, remote, effect maker, protobuf, positioning, PDF, network authorization, multimedia, Lottie animation, location, language server, insight tracker. I'm not sure, let's remove this thing. Image formats, HTTP server, data visualization in 3D, connectivity, NFC and Bluetooth charts. Okay, so let's go with this selection. So I said custom, and then I've selected Qt6.5.0 and unchecked a bunch of things. WebAssembly because this is for web browsers, which I will not use. Android because this is for mobile phones. 3D things I will not do. The ID is already pre-selected. CMake Ninja pre-selected. I've selected OpenSSL, I'm not sure why. And I kept Qt Design Studio, although I have never used it and I do not know how to use it. Okay, next. Agree to 5 open source licenses. Next. 13 gigabytes of disk space. So the packages have the extension tar.xz and they're accompanied by a checksum of type SHA-1. So whatever I have selected in the preview with components, now it's being downloaded, then it will be checked to make sure that the download is correct using the SHA-1 sum. And then they will be installed in the correct order. HTTP server is a technical preview in Qt 6.5.0. This database 3D I should have unchecked. Okay, so it has finished downloading. No, it still downloads. So this is the installer framework. This is the Qt maintenance tool, the thing that you cannot uncheck. Okay, now it downloads the packages with extension 7-zip for the Qt Design Studio. Other packages have the extension zip. Other tar.xz, other 7-zip. Qt 6.5 documentation. So it needs to download 3 gigabytes of packages. Okay, so let's pause for a second. Okay, so first it has downloaded the sources, so the source src archives. And then it has downloaded the binaries, which have such a Red Hat Enterprise Linux 8.4 part in the name. And then it's extracting each archive and putting it in the correct directory, which is still the Qt with an uppercase Q. Okay. Then it creates icons in my start menu. Installation finished. So tilde slash dot local slash share slash icon slash high color. Okay. So that's it. Next, open Qt Design Studio readme, launch Qt Creator, launch Qt Design Studio, finish. Okay, let's see where they are. Qt Design Studio. I'm not sure how to start that thing. Let's see, Ctrl D, uppercase Q. Qt Design Studio, bin, F3. I'm not sure what this thing does. Okay, back. Okay, so back at Qt Design Studio. And this time has started just once, not a million times. Channel mixer UI.qml. So this is a QML forms designer, which is used integrated into IDEs, and it uses 2D, two-dimensional space. Okay. Tab buttons, dials, push button. Okay, so enough playing with Qt Design Studio. Let's go back to Qt Creator. Okay. And it says, would you like to take a quick UI tour? Let's do that. So mode selector, we can choose between editing text, so source code. These are in projects. We have the CMake settings. In design, we have the designer for QML files, but we also have the designer in, we have the editor in the design tab. Okay. Kit selector, so in here we select if we want a different Qt framework than the one that is installed in /Qt directory. Run without debugger, run with debugger, build, locator, C space for jump to class, F space for opening files. Issues, search results, application output, compile output, QML debugger console, test results. And there's more, for instance, for the CMake output. Progress indicator. Escape to editor. Pressing the escape key brings you back to the editor. Press it multiple times to also hide context help output, giving the editor more space. So if you have various tool windows open, such as, I don't know, search results or compile output, pressing escape will get you to the text editor and will minimize those tool windows. The end. Great. People anyway. Okay. Let's open a quick QML sample. This thing. QML app using Qt quick controls. So using buttons, menus, checkboxes, etc. So controls, UI controls that are made for desktop use cases, but that also work on mobile phones, on smartphones. Presents a sample HTML file using the text area control, preserving the HTML formatting. Two user interfaces, one for traditional desktop platforms and another one, simpler one with for smartphones. File dialog, QML, Qt quick control. Most QML objects are defined like this in JSON-like format and have a name. So the name is ID colon then the name, whereas this thing is the type. Okay, so type font dialog and the name is with a lowercase f. Okay. This is help. It's already opened running the example. Open the welcome mode and select the example. We did that. There's a C++ backend. Qt quick controls text editor. Let's minimize this thing. Okay, and what doesn't it like? The project's editor is not yet configured, so I need to go into projects mode, which is this thing, and do what? Configure project. Let's click on configure. So it uses CMake, which is great, not QMake or QBS. File is not part of any project. No compilers set in kit. What do you mean by that? No C++ compilers found. No CMake CXX compiler could be found. I told you to install GCC, G++. Qt Quick application, choose, let's use my today's directory. Next, cmake. Next, details, manage. So it tries to use /usr/bin/gdb, and it's searching for a GCC. So I guess I need to install it from my Linux distribution from the binary packages. So let's do that. Sudo to become super user. Apt install build essential G++. Apt install cmake GCC. GCC is already part of G++. Autoconf. Automake. Suggested Ninja build. Cmake format, cmake doc. Okay. Let's reopen these things. File, new project, Qt Quick, choose. Entitled to. Next, next, next. Details, manage. And now it has found the C++ compiler G++ at /usr/bin/g++, or /usr/bin is the directory where my Linux distribution, which is Ubuntu 23.04, installs binaries. So looks okay. I only want a debug build configuration. Next. No version control. So it creates a main.qml, main.cpp, and cmake list.txt because it's a cmake a C++ project that uses the cmake build framework. Okay, so the QML uses qtquick.window, which is a library. Qtquick is the default import. Most QML files import Qtquick. Okay, what does a window do? A window is a QML type. So QML types, as far as I know, start with an uppercase letter by convention. Creates a top-level window. it automatically sets up the window for use with Qt Quick graphical types. Transient windows for the outer windows. When the user attempts to close a window, the closing signal will be emitted. You can force the window to stay open to prompt the user to save changes. Windows position and size, so X and Y is relative to the screen if there is one, or to the virtual desktop. Minimum height, minimum width. An interesting type. I didn't know about window. So let's see the other files. There's a main.cpp, which is a C++ or the entry point function to this executable, which exports the standard C++ function int main int argc int argv. So it states that this is the main entry point to the executable. This return type will be the exit status of the executable when the executable finishes, the process finishes. It takes this number, it has this number of parameters when you start this process at the command line, and this is the list of command line parameters as UTF-8, probably char pointers, so strings. Okay, let's put a breakpoint here. What doesn't it like? The file is not part of any project. I cannot save anything. The code model might have issues parsing this file properly. Fail to load the project. Issues and projects build. Projects build. CMake project configure failed. No CMake configuration for build type debug found. Okay, so the CMake actually failed. Could not find OpenGL library. Okay, let's do that. So I need to install more packages from my Linux distribution, it seems. Let's set up apt file. How do we set up apt file? Just a second, let me search this thing. Okay, so this thing, apt install apt file. Yes. Apt file update. Okay, and then apt minus file space search, and then case insensitively or not, the CMake file that's missing. Okay, so let's read what it says. So it says OpenGL library, and OpenGL GLX. Apt file search. Nope. Doesn't say the name of the CMake file that's trying to find. Wrap OpenGL. Not exactly sure what, if this is a CMake package or a package config one. So there's a CMake file which probably uses package config. Okay, so let's find them in a different way. Apt search wrap open. Not like that. Let's search using the Ubuntu packages search. Wrap OpenGL. Okay, so this is a cute thing. What about GLX? Does not work. We need a dev package because GLX is probably a C library and we want to use its headers. So I'm guessing this guy. This first. Okay, let's run configure again. Build run CMake. Could not find OpenGL. What is that? Lib OpenGL dev. This thing. Yes, so I have libopengl installed, so the SO files, but I do not have libopengl dev installed, which contains the header files, the .h files. Okay. Can we clean this thing? Yes. Build, run cmake. Could not find OpenGL glx. So we did OpenGL underscore OpenGL, and now we're down to OpenGL glx. Okay, so what's installed is libglx and libglx mesa, these two. So I guess I need to install libglx dev. I don't see anything else with dev. App install, middle click paste. Okay, build, run cmake. Scroll down. Okay, the previous run of cmake, its output is grayed out. So this is the last run of the cmake. So says could not find OpenGL include directory. What is that? Let's just search on the internet. Ubuntu Ctrl V. Let me Google that for you. Wow, great. Mesa common dev, libgl1 mesa dev, and libglu mesa dev. Why? What's the correlation between could not find OpenGL and libgl1 minus mesa minus dev? Mesa, an implementation of OpenGL. Interesting. So could not find OpenGL means libgl. Could not find EGL means libegl with an extra E, which is not our case. Okay. Let's search for this thing mesa and dev. Okay, do I have any mesas installed? libegl mesa, libgl mesa dri, libglu mesa, libglx mesa. Okay. So So this thing. Back to the previous list. libegl1 mesa dev. Do I need this thing? So the SO files are installed, but the .h files are not installed. libglu. This is probably going to be needed. libglx. Let's also install this one. So the SO files for libglu1 mesa are installed, but the .h files are not. So let's install them. Copy. Ctrl-Shift-V. Okay, clean cmake, build, run. So clear, what's it? Run cmake, this thing. Okay, so says found OpenGL, found rep OpenGL, which is just a cmake file inside of the Qt framework, rep OpenGL, whereas OpenGL needs to be installed from my Linux distribution, and depending, we either use Mesa or the NVIDIA binary OpenGL. Could not find XCB. I know what this thing is. Grep dev and XCB. There's a million of them. XKB. Okay. So XKB dev could be two things. Could be either XCB or without XCB. So I'm not sure which one. Both are installed libxkb common and libxcb xkb. So let's try this one first. So could not find xkb. So it's the other one then. libxkb common is installed, so .so files, but not .h files. Okay. Clear, build, run cmake. Found libxkb common. Could not find Vulkan. What is that? Okay, so libvulkan1, so the SO files are installed, but the .h files are not installed. So let's do that. Install, middle click, paste. Okay, clean, build, run cmake. Found wrap Vulkan headers. Qt policy is not set. I know. Call stack QML macros. This is a warning. Okay. Configuration done, generation done. So now I have all of the needed packages from my Linux distribution, such that at least the minimal QML application that I can create in Qt Creator using the Qt Creator wizard for QML applications work. So right now I can go build, and compile output is happy. I can go run without debugger, and it shows me a empty window. Press escape to close some, to free up some space. So the main.cpp finds a resource, QRC, named untitled2, which is the name of the project, which is a namespace. And then inside of that, there's main.qml, the QML file. And it loads that file in the QML engine, QML application engine. And it connects QCore application exit -1 if it could not parse the QML file. And then it enters the main loop. And main.qml says that a window should be created, in this case an X11 server window, with the title translated. So this is the translation function for internationalization. And this is the title in English, Hello World. And the size of the window should be 640 by 480, should be visible. Okay, so this is the simplest QML application. Not sure what these things are. Okay, so this is the projects view. The other interesting view is file system. If this actually would start from untitled2. Which is this thing. Okay. Where do we go next? Let's see an example. Maybe additional the packages will need to be installed. So these are the examples. Let's go through them. QML media player example. Configure project. General messages. In here it has run cmake, and it's successful. And we can select debug, and we can run the application. Okay, let's press play. File, open. There's no files to open. So this probably uses Qt Multimedia, which is the audio video framework from the Qt project. Okay, this seems to work okay. Another sample. File closer projects and editors. QML recorder. Okay, configure the project. Has already been configured. We can run it. Let's start. No video or audio input. Incredible. Which is true. Close all projects and editors. The text editor. So CMake configure has failed because this thing was already configured previously. Okay. How do we delete this configuration or the CMake configuration? Build, clear CMake configuration, build, run CMake. Okay, and now it worked. Let's start without debugger. Okay, so we have a toolbar with buttons, a file open dialog, QML types menu from qt.labs.platform. A menu bar from the same place. Menu item, still qt.labs.platform. File dialog. Let's actually look at the source code, so QML. Plus touch. So it uses qt.labs.platform as platform and Qt quick controls. Okay, how do we switch between the touch-friendly UI versus the desktop-friendly UI? If the app arguments contain -touch, so let's do that. Projects, run text editor example in run configuration, and then additional command line configuration parameters, touch with a minus. Okay, and run. Okay, so this is a smartphone. It has the buttons at the bottom because there's where the right hand thumb is. Toolbar at the bottom. Hamburger menu for about. Let's make this mega bold. Okay. File, close all projects and editors. So what else is here? I do not want to look at 3D yet. Qt Quick controls gallery. CMake configure was happy or not? Configure project. Okay, and in general message we have the output from CMake configure, which is happy, and now we can run the project. Qt Quick controls. So Qt Quick is rectangles and colors and styles and everything. But then on top of that, there's another library which is called Qt Quick Controls, which provides checkboxes and buttons and other graphically user interface elements that are expected to exist on a desktop, such as Windows OS, Mac OS, or Linux. Okay, let's resize. How much do we need to resize it until the hamburger menu converts into a tree view? Material. So it says start required. So this is material, which means the Android-like style. Okay, so the message boxes appear inside of the window. They're not modal outside of the window. Let's go back to the default style, which is Fusion. Group box. How do I use my keyboard? Up and down. Does not seem to work. Okay, so there was one version 1 of this library, Qt Quick Controls 1, but nobody uses this anymore. We use the latest version of Qt Quick Controls, which is at least version 2. Okay. Group box. Progress bar. Okay, let's go back to the project Untitled 2. What are you doing? This guy. So in here we had the main.cpp. We put a breakpoint inside of the entry point function of the executable of the process, which is the int main function. And now, because everything's configured correctly, CMake configure is happy, we can use the debugger. We've also configured to use the debug build configuration. So this means in the switch to projects mode, Control 5, build and run, build, and then in here we select build settings, edit build configuration, we select debug, which means no optimizations, and do not strip debug symbols. So the process will run as good as possible inside GDB, the GNU debugger, which is actually used by Qt Creator. Okay, so let's press the button. So I have application output. It writes some numbers. Internal error. Okay, QML debugging is enabled, which means debugging for the JavaScript parts of QML files, which means bindings and functions and event handlers. So it creates a QGUI application, which is not from Qt Quick QML, but from Qt maybe it's a common part for Qt widgets and QML. Yeah, it doesn't really say that it uses Qt widgets. Okay. And then it loads a QML application engine. We cannot step inside of this because we do not have apparently CPP files from the Qt framework. Let's jump back here. How do we jump here? We put a breakpoint at line 10, and then we go debug and continue. Okay. Sometimes tooltips become sticky, and you need to unstick them. Okay. So it says const QURL converts a string to a URL type, and then it provides some implementation if the QML source code is invalid. It will exit the application with exit status -1. This is a C++ lambda anonymous function with closure. So this says the return type, this says the parameters list, and this is the body of the function. Okay. So it connects the engine's object creation failed event to this lambda. Okay. And then engine load URL, it tells the engine to load that absolute path, this thing. And then app.exec is the main lookup of the application. Again, we do not have source code for the Qt framework F5. And since the main loop is not posed in the debugger, we can actually use the application. It's not becoming unresponsive. Okay, we can either continue debugging, which will immediately stop, or press the stop debugger button. So let's go continue. File, close all projects and editors. And now the next thing is to actually start the tutorial. So let me start the tutorial. Okay, let's go to the start of the video. Okay, so we've started the tutorial, and in here we are being told that we will have a separation between the business logic, so the implementation of events, the constructors connecting to databases, connecting to the internet, anything that's not related to graphical user interface, display, views, interaction, mouse, keyboard, touch, events, display is going to be written in C++, and the GUI only things are going to be written in QML files. Okay. So then it goes to a Hello World application, which in this case it's not even using the integrated development environment Qt Creator. So let's do exactly what the tutorial does. Let's make a new directory in here. Hello. We'll create a file named main.qml, Shift F4, main.qml, should open with the KDE text editor Kate. It does. Okay. And it says import Qt quick, and it puts the version 2.0, which I guess is not is a warning right now in Qt 6 to have version for imports, but we'll see. Text and text. Hello world. Okay, so we've created a file. We have no clue if the syntax is correct. This is a good moment to find out if we're using types that actually exist, we're using properties that actually exist, this thing actually exists. So let's look up. We can either, because I'm in the KDE Plasma desktop, I can go F2 and then Qt, colon, and then QML text. And it does not work for some reason. Control D. So QML and text. It goes to the correct place, QML Qt quick text, to the correct type, which is text with the uppercase T, which is part of Qt quick. Everything's correct. And does it have a member, a property, something that's named text? Match case. Yes, it does. So what is this? This is the string to display, plain text and rich text strings. The item will try to automatically determine whether the text should be treated as styled text. This determination is made using Qt might be rich text. Detection of markdown is not automatic. Could be markdown. Or could be this thing. So text.styled text is an optimized format supporting some basic text styling markup in the style of HTML 3.2. So it's a subset of the HTML programming language. Rich text is another thing. So this was styled text. And rich text supports a larger subset of HTML4. Better performance if you do not use rich text. Okay, so let's do Markdown. Let's see if this thing works. Do we know Markdown syntax? Not sure. I don't know. Okay. And the detection of Markdown is not automatic, so we need to go text. Where are you? Text format colon and this thing. Control V, Control S. Okay. How can we make use of this file? We have executables. So we have QML scene. Okay, not available. Which QML scene? USR bin QML scene. This is the wrong one. Which QML? Okay, so let's create open a console in here. So a terminal. And actually put the bin directory from this Qt installation that I have installed from the Qt website using Qt Online Installer as the first thing in the path environment variable. So that's 650 GCC and bin. Is there a QML executable here? Yes. Is there a QML scene executable here? Yes. So I want this thing to be the first in path. So echo $path. Okay. And path equals, let's even export it. Paste, and then the rest of the environment variable path. Like this. Okay. Now, which QML scene shows the correct QML scene, and there's more than one QML scene executable on my machine. In /usr is the one installed from Ubuntu 2304 deb packages, and in tilde/qt is the one that I have installed from the Qt website, qt.io, using the Qt Online Installer. And the one from the Qt Online Installer is preferred. Okay, so let's go QML scene, and then the name of the file main.qml. Okay, so it says QML scene is deprecated and will be removed in a future version of Qt. Please use QML instead. So let's do that. just QML again, which a QML exists, QML, and then tab to autocomplete. There's just one file in the hello directory, which is called main.qml. So when I press tab, it knows what to autocomplete. Okay. So it has the correct icon from the Qt framework. It has the correct content, which is markdown, which is a bullet point, unnumbered list, and then the text hello world. Okay. Let's use quarter tiling. We can even go one step further and use the terminal inside of Kate, where we'll do the same things. So export this thing. Let's open another Kate if possible, where we keep the notes. New file. So we're on Ubuntu 23.04. We have Qt Creator and Qt 6.5.0 from where are you? Qt.io website using the online installer. Hundreds of deb files were missing. A G++, lib Vulkan dev, testing, XKB. Okay, what else? Many packages, and these deb packages, once you install them, they will depend on other deb packages and will automatically download and install those too. That's why at the end you end up installing hundreds of deb files. I do not know how to install all of the relevant X11 dev packages on Debian-based operating systems. save my work. So work daily, year, Q, and day. Okay. What else? I have run. So inside creator, I have created the default QML app project. I have run some QML example and loaded and some QML example projects on the welcome page. Okay, like this. So we're at the Hello World step in the tutorial. We know how to create a QML file. We know the syntax a bit. So this is how it looks like. Says import Qt Quick. Did not complain about the fact that I have used the version, but in QML, in Qt 6, as far as I know, you should not use version for your imports. Then we're using a QML type, which actually still exists in Qt 6, which is called text. So this is the type. Again, starts with an uppercase. It inherits from item. All QML types inherit from item. So item has anchors for positioning in the parent, inside of the parent control. Children, parent, relationship, height, width, implicit height, implicit width. So it's basically a rectangle. And there's also a specific type for rectangles, which is called rectangle. It inherits from item and has very few extra things on top of the QML type item. Just color, gradient, radius in order to have rounded corners, and border color and width. Okay, let's actually do this rectangle. Control S, Control C, Control V, save as rectangle, QML. Okay, let's also note this thing. In and the nodes. So cd to where you're working. And then you make sure that at the start of the environment variable path, there's the directory from the Qt online installer, the version of Qt that was installed using the Qt online installer. And then you use QML and what's that? Hello.qml. Control S. Okay. So we go QML and then rectangle. I pressed RE, just two keyboard keys, and then tab for auto completion. Okay, so again, rectangle on top of item has rounded corners. It says radius 10, so radius of 10 pixels or something. And it has border color. We've made it black. Has a border width. We've made it 5 pixel. And a color, which is in this case red. Okay. Let me see if we can open this file in a QML editor to see how it looks like. Control T. Qt Design Studio being this thing. Okay, how do we create a project? Let's use the projects directory, this P directory. Make this smaller. So op.qml, QML project. What's this? Open file or project. P hello and only opens QML projects. Don't we have a previewer for this thing? Where was I? We'll get there to actually editing this file. Or we can use Qt Creator for now. File, new project, Qt Quick application, choose. Okay, so we have main.qml and we'll replace the body of this file with this thing. Okay, Control S. How do we open it with editor? There's no design button. So at least we know the types. So this is QColor, width is an integer, is a double, radius a double. This is of type color. This is of type double and double. I pressed F1 and it took me to the help of item. Radius is 10 and is a property of rectangle QML type. So it took me to the correct place in the documentation. F1 on rectangle, F1 on width should take me to the item.width. Correct. F1 on height, item.height, correct. Rectangle.color should go to rectangle. This thing. Okay. Border.color is from rectangle. What about border? Nope. It should go here to quit Qt Quick QML rectangle border property. If I click on border and press F1, but it does not. Okay. This is probably some bug in the documentation. What about black? QColor class. Okay, let's see what this thing is. So there's a method which is called black, which is actually a property getter, I'm going to guess, which is probably a Qt property, so Qt style property. So there's black, black F, blue. So this is the float, blue as float, and this is blue as integer. Okay, so border.color is actually a QColor. Okay, so we could use cyan Do we have auto completion in here? Control S. How do we run this thing? We can't, because why? We didn't build yet. CMake configure was successful. Compiler was successful. But it will not debug or run. It only has a QML file, does not have a C++ file. It does. It's looking for main.qml and it found it. File close all projects and editors. File new project application Qt quick application choose this directory. Next, next, next. Manage, where are you? Cancel, details, uncheck all of these. Next, next, and run. It works. And this thing is not visible. Just a rectangle. Because why? Why must I use a window? I'm not sure why. Okay, so I'm missing a editor, a GUI editor, so this design tab. And I do not know yet how to edit inside of a safe environment a QML file. Because if I'm editing the QML file just in a plain text editor, until I actually run it with QML, I do not know if I have any errors there. Okay, let's continue with the tutorial. Okay, and now it says that we can go one step further and actually create a file named main.cpp that will launch that QML file. So let's actually do that. So let's look at the main file. Import Qt Quick to text and text format. Okay, let's simplify that thing. Control O, main, this thing. Can't we make the date smaller? Cannot. Okay. Let's not use markdown. Control X and just hello world. Control S. And create a main.cpp file. Control O. Main.cpp. It cannot open files that do not exist, which is ugly. Okay, so let's write them by hand. Include Qt quick int main int argc char pointer rp QGUI application up arg c arg p. So this is very similar to what we have here. So it says include Qt quick int main argc argv QGUI application up argc argv Qt quick view and then up exec. Okay, a bit different. Q quick view view dot set source QURL main.qml view.show return app.exec. Control S main.cpp and let's see how we compile this thing. Okay, and it uses QMake. So Control O, where are you? Control new, sources, main.cpp, Qt plus equal quick, headers plus equal no headers. Control S, and this is hello Qt quick. .pro. Hello Qt quick.pro, sources equals main.cpp, Qt plus equals Qt, nothing for headers, and we can use QMake, which minus a QMake, correct, QMake, qmake and then files. Let's look at the files. So there's a .pro file and it created a make file. Interesting. Okay, could not find the include for Qt Quick because it what? No such file or directory Qt Quick. Yeah, this thing might have changed because the tutorial was made a number of years ago in Qt 5. Just a second. That was not it. The problem was that I used the incorrect syntax on line 2. In hello qtquick.pro I had a lowercase t in here, so it should be uppercase T. And then I ran qmake to generate a make file in the current directory, which is this file. Which has actually done a ton of work. So it has identified the directory where I installed Qt based on the path environment variable. It has added the include directories for Qt Quick, Qt OpenGL, Qt GUI, Qt QML, Qt QML models, Qt QML integration, etc., etc. Okay. And then using this makefile, I'm using GNU make in order to build a default target inside of the makefile, which is this thing. Okay, so for that I'm using GNU make, which can be invoked either by calling make with the 0 parameters because the makefile has the correct default name, which is with an uppercase M, no extension, makefile. Or I could use one of its aliases, such as gmake, or I can use the full path, which is /usr/bin/make, which I installed from the packages when I went apt install build -essential and apt install g++. Okay, so make. And this complains that there's no such thing as qquick show with an uppercase S. Do I want to use a lowercase s? Of course I want, because methods are named using not Pascal casing, so with an uppercase on the first position of the name, but with a lowercase, so camel casing. I just ran make. No need to rerun qmake because I didn't change the name of any file. I did not create any new file. I just edited the content of a file. So for that, the make step is enough. Okay, so it says it's successful, which means it has created an executable in the current directory, probably, which is called the same name as the project file. So hello qtquick.pro, which is the qmake project file, has created the executable hello qtquick. And an intermediate file, main.o, so O for object. Let's run hello Qt quick, make sure it's executable. So ls-la. The only executable file in this directory is actually the executable, which is hello Qt quick, the binary one. So we can execute this one by giving a relative path, so /hello Qt quick, and this is it. Okay, so as first examples, we have done only using terminal and a text editor, created the first hello QML executable. So this 17 kilobyte executable hello quick. Okay, so we have managed to create the first executable that uses actually QML behind the scenes. So the C++ parts have been converted to an executable, which is hello Qt quick, has 17 kilobytes, and then this executable uses a ton of other .so files. Let's actually look at that. So for that we use ldd and hello quick, this thing. So this is the explanation why the executable hello Qt quick, which contains all of the C++ source code converted to binaries, to x86-64 CPU binary code. Only the executable, the final file, only has 17 kilobytes because the rest of the native code is in .so files, which, if you combine the complete size of all of these SO files, the size is going to be probably more than 100 megabytes of files. So there's libqt6 quick, libqt6 GUI, libqt6 core, the standard C++ library, the GCC, the compiler library, the standard C library, libqt6 Qt models, which we have already actually seen as part of the makefile. In here, this thing. libqt6 QML, libqt6 network. So these were all here, libqt6 QML, libqt6 network, libqt6 core is this guy. Okay. Then we saw libxkb common so, because we needed to install this package for the header files, for the .h files, for the include files. Then libqt6 OpenGL, yeah, we saw that with the need to install header files for Mesa, for glx, for OpenGL. Okay. Then libgl.so, libm, this is, I don't know, what's this, the multi-precision part of GNU, the toolchain. libpthread, which is POSIX threads for Linux. libegl, which might mean that this executable does not use glx and uses egl instead. We'll see immediately. Font config, because we have shown fonts on the screen. x11, DL, part of LDD dynamic loading library. glib, the GTK base library for the Qt main loop. libqt6 dbus, libz, which is zlib, which is the simplest compression algorithm that exists on Unix and Linux, which is files with extension gz, libfree type for fonts, libgthread, probably still from GTK for threads, ICU, the I don't know, IBM or whoever maintains this application, ICU for internationalization, or Unicode code points, or locales for local sorting order, etc. libicu UC libicu data. Then librt, which is probably part of GCC. LD Linux. GSS API Kerberos. GL dispatch. So this is for supporting both Mesa and NVIDIA OpenGL binary SO files from a single code base. libglx, so both EGL and GLX, which is interesting. XPath for XMLs. XCB for the C-style bindings over X11 libraries. Per compatible regular expressions too. Again, dbus. PNG for encoding, decoding PNG image files. Broadly for lossless compression, so similar to zlib. Kerberos 5 again. This is probably also Kerberos, I don't know. libcom-r, no idea what this thing is. Kerberos again. X libraries, AU, DMCP, systemd, again broadly for compression. I don't know what this thing is. libresolve, not sure what this is. BSD cap, this is for terminal capabilities. gcrypt, this is compression library. LZMA, Z standard, LZ4, and libgpg error for GNU privacy guard, pretty good privacy, so PGP, GPG. Okay, so again, if we combine the total size of all of these files, the final size will be more than 100 megabytes. And just on top of that, you only add this 17 kilobytes for the code that's just in the executable, not taken from other shared library, plus the main.qml file, which is referenced from the hard disk, not included as a resource, as far as I know. It says take from the current directory a file named main.qml. Don't look in the resources of this executable. Okay, so we've run this thing. We know how to view the QML file. QML. Okay, we can also run it using the executable. Okay, and there's one more way of running. So yes, there's the QML scene, which is deprecated, you should not use. So it complains, it says you should use Qt instead, QML instead, the QML executable instead of the QML scene executable. And then there's even one more way of running this thing, which is What extension should we put to this thing? It's a comment. Yeah, so we can edit the QML file itself, and let's see if it allows comments with shebang. And QML, Control S, and it's still valid QML file, even if we've added a comment using the # sign. Hello Qt Quick still likes the file. Let's actually edit the file and see what what the executable does. So it shows the new string, which means that Hello Qt Quick actually uses the file from the hard disk main.qml. Okay, and we can actually make this file executable. Permissions is executable, okay, and now we can run it. What's the name? Main. And auto-completion also works because when I say /, Bash knows that I'm trying to autocomplete for files that are executable, that have the X chmod bit set. So there's just two files which are executable in this directory, hello Qt Quick and main.qml, and if I go /h and I press tab, it will autocomplete hello Qt Quick because that's the only possibility. And if I go main tab, it autocompletes main.qml because that's the only file that has the name starting with M in the current directory and is executable. Required file not found. Why not? Because env cannot find the QML. It can. Okay, it should have worked. I'm not sure why it does not work for me. So should execute the current file, which is named main.qml, using env, which is an executable, which exists in /usr/bin/env with QML as parameter. So it should actually run env QML and then the name of the current file. You can make scripts using the QML binary. Okay, I'm not sure why it does not work. Not a problem. Let's go next in the tutorial. Env QML, shebang. Okay. I did qmake, I did make, I ran the executable. So now we're talking about the history of Qt and QML. It says that QML was started by two friends in 1994. They created a company named Trolltech. Trolltech was bought by Nokia in 2004. So Nokia was the king of mobile phones. They had, I don't know, 50% market share, and they had an operating system that's called Symbian, where that was supported by Qt, the Qt framework, so the Qt widgets. And they bought Nokia. Nokia bought Trolltech in order to buy the Qt framework, not to buy any Qt framework commercial licenses anymore. And they open sourced Qt in the sense that they made it an open project, and probably the LGPL, so some changes in the open source licensing of Qt. Okay, then it was spawned out by another company named Digia, and in 2012 and in 2014 the Qt company was formed. Okay. So at Nokia they wanted a new programming language, engine, etc. technology inside of the Qt framework that enhances the Qt framework, that uses the Qt framework, the C++, Qt libraries, the meta object compiler, C++ additions to the so the Qt additions to the C++ language, again, introspection, type info, Qt objects, Qt method, Qt properties, Qt enums, Qt signals and slots. But they wanted 4 design philosophy principles. Intuitive user interfaces, so that means mobile phones, smartphones, swiping, zooming, pinching, infinite scrolling. Design oriented, so that's what you see when you look at Qt Design Studio. When you open a random project, it uses a file which has the extension QML project. So this is actually describing the project that's loaded currently in the IDE or in the GUI tool for designers. So there's 2 GUI tools, one for designers, another one for developers. For designers, there's Qt Design Studio. For developers, there's Qt Creator. Designers would work just in files with extension QML project and files with extension QML or UI.qml, and create beautiful user interfaces which they can run. The user interface doesn't do much, but it's enough for the designers to see if their design is okay or not. Okay, and then the QML, all of these files are taken by the C++, the programmers, and the programmers add the rest of the bits, so the C++ models, controllers, data access layer, object relational mapping, async, HTTP requests, JSON parsing, and etc. So the business logic. And the business logic is either written in C++ or in JavaScript. If it's written in JavaScript, then it's easier to do rapid prototyping and production, because just by sending all of the changed files in the current directory to your mobile phone, the application will immediately run on the mobile phone, because all of the files are actually interpreted if they're JavaScript and QML. Once you add CPP, C++ source code, then you will need an additional step where you build that C++ source code into binaries. Maybe your computer is using Intel CPU x86_64, and the mobile phone uses, I don't know, ARM ARch64, so you need to build all of the CPP files twice for the two different CPU architectures. The binary files, so the SO files and the executable for ARM will need to be copied over SSH to the mobile phone or over USB, whereas the binaries compiled for Intel, you will need to, in order to run inside of the debugger, so to run the same application on your machine. Easy deployment, again, just copying a bunch of no arch files. So the C++ source code is compiled down to architecture specific binary code, whereas QML and JavaScript is no arch, so is CPU architecture independent, can be just copied over, no need for a compilation step. It's interpreted by the engine that already exists on the mobile phone. So that's the easy deployment. You just copy files, no intermediate compilation step. And copying is, of course, incremental rsync style, so only the files that have actually changed are going to be sent over, or maybe just the parts that have changed in the file. Rapid prototyping means you can edit inside of the GUI the QML file, and you have instant feedback inside of the GUI forms editor, and you can immediately run it and live replace existing QML files, etc. So rapid prototyping and production. Okay, but what actually came out is that maybe using JavaScript for the business parts and making the application so easy to deploy is going to be a problem when you take performance into account and the other limitations that you have in JavaScript, like no compile time type checking. Do you have threads? Can you reuse the JavaScript parts and JavaScript models and JavaScript view models? How do you access the database, etc.? So again and again, this tutorial reminds us that we might play with JavaScript for a while to create the backend part, but in the end, we'll still end up and use C++ for the backend code. Okay. What else? So there's the Qt framework, which uses OpenGL right in version 6 it also has a abstraction layer on top of OpenGL such that it supports the native 3D graphics acceleration API on each platform, so OpenGL or Vulkan on Linux, DirectX, Direct 3D on Windows, and Metal on iOS and macOS. Okay, there's Qt Quick, Qt Widgets, Qt Graphics View, OpenGL, WebKit, not WebKit, Web Engine, Qt 3D. Works on the three desktop operating systems, Windows, macOS, and Linux. And the Qt framework open source part was also ported to many other operating systems, such as the BSDs, etc. Okay, and then it exemplifies the embedded operating systems with a real-time kernel-only mode QNX operating system, and for smartphone OSs, Android and iOS. Okay. So now we're inside the Qt Creator, and somehow he has the design button working, which I do not know how to do that. So this button, this design button. Just a second, let me see, maybe I can make the QML forms editor work inside of the Qt Creator DID. So it seems that the Qt QML designer is disabled by default. So it's probably this one. So I reopened Qt Creator, help, about plugins, and it says Qt Quick and QML designer. Okay, plugin changes will take effect after restart. Restart now. Okay, now let's create a new project, file new project of type Qt Quick, choose correct directory untitled 10, and next. Okay, let's make sure we're using debug. Okay, untitled 10. And now we have the button switch to design mode control 3 enabled. So let's do that. And it restarts in this interesting mode, which resembles Qt Design Studio. Okay, and there we have main.qml. It says it's a window, and we can see the values that are not default. So there's no ID, there's a size, a width, and a height. How can we see the source code? There should be a button in here. Okay, I need to switch back and forth like this. I don't like it. We'll look for it. Okay, so now we finally have most of what we want from an integrated development environment from an IDE. We have wizards to create a new project, so file, new project, and Qt application. We have a tree view that shows the CMake project structure, a tree view that shows the file system, a editor which supports QML, has syntax highlighting, code folding, has some limited help. So I put my cursor on KSTR, pressed F1, and it indeed went to the correct place. Okay, then I can see the type of a member by hovering on it. It says int, it says bool, and it says qstring. We can see that in QML the type used for strings is actually qstring, which is the type, the string type in Qt. Okay. Some help about libraries. It says where the QML import library is located. Okay, and we have a forms designer, what I call this in forms editor. So a way to edit visually inside of the IDE the QML file. So this design tab. Okay, it would be nice if I can see at the same time both the QML source code and the forms editor. So this is available in XAML, in Visual Studio, at least. Maybe I'll find such a thing. Okay, then we have the CMake build tool. So we have build run CMake, build clear CMake configuration, build run CMake, and then build project Ctrl B, which is the same thing as clicking on this button on build project untitled 10 Ctrl B. Then I can run the entire application without debugger, which means that the integrated development environment is configured correctly to use the correct Qt installation and can find the correct files from the current directory where we're programming from, which is this untitled 10 directory. And we can also debug the C++ source code. Let's close some of these. Okay, F10 to go next. Stop. And we also have a JavaScript debugger. So if we have complex bindings or complex JavaScript event implementations inside of the QML file, we can actually see what's happening. I don't know how to do that yet, but we'll get to that soon enough. So all of the things can be done just from clicking buttons inside of the Qt Created IDE. I don't need to use the terminal for now. Okay. And now let's do what the tutorial does. So again, why are we forced to use window as a top level thing? Okay. Let's exercise this file from so without using CMake or C++ at all, and this way we can start incrementally. File, close all projects and editors, and we'll create a QML file. Let's call this thing hello2. We create a file in there. Which is named X expressions QML. Shift F4 X minus expressions.qml. Okay, so says import Qt quick 2.0, and the most basic Qt quick QML GUI item is control is named item with an uppercase T. And this has a width and a height. .400. We can put more than one instruction on the same line. Not recommended. Okay, since this programming language resembles JSON, you probably can end lines with a trailing semicolon. Rectangle is one of the most basic types that inherit from item, just adds 4 more properties. X exists on item. Okay. Y exists is a property of the type, the QML type item. Height, width, also are properties of the type item. And now we do a binding. So all of these values for properties are literals. So on one of the basic types, there's int, there's double, there's qstring for strings, and bool. But for width, we do not have a literal, we actually have an expression. So height times 2. And then color. This we have seen that it's of type QColor with an uppercase Q, uppercase C. So the basic color type in Qt. And light blue is actually a property of QColor, a getter method. Control S. Let's open this file in Qt Creator. So File, close all files and projects. File, open file or project. Hello2, X expressions, open. The design mode requires a valid Qt kit. So we don't actually have a project file for this file. x-expressions.qml is a single file, and when we open in Qt Creator, we want to open projects, not files. Okay. Width is double. Okay. So for that, the simplest thing that we can create is a QML project. So a file with the extension QML project, the same that we saw in Qt Design Studio. So let's create such a file. Add new. Is there a file? Empty file. Choose. Okay, and it has the same name, x-expressions.qml project. Finish. Okay. And let's look at the content of the QML project file. So says import QML project 1.0 project main file with camel casing x-expressions.qml and QML files just one. This also looks like JSON. So we say not one QML file, but all of the QML files from the current directory. Okay. And now we want to open this project. Okay, so previously we have closed all of the projects and editors in Qt Creator and then opened this file. And now we've closed all of the projects and editors and opened the project, not the file, x-expressions.qml project. We go open. Let's see what features do we have. We have the feature of running without debugger. We have the feature of running with debugger. Just a second, let me see where the breakpoints are. Okay. And let's stop the debugger. What else? Let's see if we can edit visually the QML file. And we can. So classical forms editor toolbar buttons. There's forms editors in the Delphi IDE, in the Visual Studio C# System Windows Forms IDE, in the Visual Studio C# XAML, WPF IDE, Forms Editor, in the HCL Notes Forms Editor, and in other integrated development environments that have Forms Editor and rapid application development. Okay, so this is a palette with controls. It's called components. Then there's the navigator, which is actually a tree view of the controls that exist on the current form. So there's a top level item which has one single child, which is rectangle. By clicking on the tree view, that item will be selected in the forms editor in here. There's the properties tool window, which in this case it's grouped by some criteria. Most forms editors all have the properties grouped, but you can also ungroup the properties to see them sorted alphabetically. And looky here, we have code now. What is this? So the default was basic view. So this is like perspectives in the Eclipse integrated development environment. So we want code. Okay, this thing is better. So we have both properties and what it states. So this is probably the machine, whatever, the state machine. We do not want this for now. Okay, let's see how live we can edit the source code. So make the rectangle blue, and you don't need to save anything. The forms editor shows the fact that you're now using blue both in the forms editor and in the properties tool window. And in here it says that the file is modified just in the tab bar of the current text editor. Fortunately, it doesn't say in the window title bar of Qt Creator ID. Ctrl S. Okay. So we have two files, a QML project, which is really simple and which is the exact same content for the file QML project. So you will always have 7 lines and 2 empty lines. You'll always have import QML project 1.0. You'll always have project. You'll always have one main file of type QML, and then it includes the rest of the QML files in the current directory. So the main file is the entry point, which is used by the debugger, the runner. It's the first QML file that's loaded. And then, yes, that QML file, the main one, might open additional QML files from the current project and from other QML directories, other QML libraries from Qt. Okay. And we currently have just one QML file, which is both the main QML file, so the entry point to the executable, and the only one in the current project. Okay. So back to the QML file, we have all of the properties are specified as a pair, so name, colon, value, and the value for all properties is a literal, so an atom. 400, 300, 150, and blue. The only thing that's not a literal, an atom, is this thing, which is actually a valid JavaScript expression, which actually does not get computed. So it doesn't look what's the value of one of the height, 100, and then it multiplies that by 2 and gets 200, and then this becomes a evaluated expression, so just 200 as a float, and then width is forever the double 200. Instead, width is assigned this expression as it is. So think of this as a anonymous function with closure and lambda and everything. And think of this as this dot height in C# or C++. So this is not 100, instead it's the life property this dot height. Let's see if this works. Yeah, it works. Okay, so height is actually this dot height. Not computed once and then the resulting value assigned to this. No, it's this entire expression, this lambda, is assigned to width. So this is called a binding. Okay. How can we prove that? When we run the application, if we resize the rectangle, so we change the height of the rectangle, then the width of the rectangle will change live. So if we bind the height of the rectangle to the height of the window, or we dock, or we anchor the rectangle, whenever we change the size, the height of the window, the height of the rectangle will also change, and then in cascade the width of the rectangle will always be double the height of the rectangle, so it will change automatically. Control S and stop this application. Okay, so we can assign to width any valid QML expression, any valid QML JavaScript function. So let's do that. We're going to create the simplest QML JavaScript function, which is named foo, which uses JavaScript functionality, which is built in, which is console.log. Hello world. So each time this function is called, we will know, because in the application output we will see the string hello world printed. And then this function will return a value that's compatible with the property rectangle of the QML type rectangle, which is of type double. Or if we return int, that will be automatically cast to double. So implicit conversion. Okay, so we can go return height times 2. Control S. And how can we comment out this thing? Control C, Control V. And calling the function foo, so not the function foo, but actually calling the function foo, is a valid JavaScript, is a valid expression, so is a valid right-hand side of a binding. So this is a binding, this is the right-hand side, and this is the name of the property. Let's save this thing and run it in the debugger. Okay, let's look at the application output. So the application output says QML hello world, which means that rectangle has asked for its width just once, and the height and the width is really big, and it exits from the item, so from the window. Why is that? Why is that? Why does it? Why is the width way bigger than what we saw previously, which is this case? Control S. Start debugger. So right now the height times 2 is 200, whereas now the height times 2, the same height times 2, is way larger. Well, let's inspect this thing. How can we do that? Do we have the inspection tools installed? It's called Gamma Ray. No, we do not have them. I'll figure out a way to install Gamma Ray in here, such that we can inspect what's happening. So give me just a second. So I searched for Qt Gamma Ray and takes me to the doc.qt.io/gamma ray, Gamma Ray user manual. And in there's a button which there's a link that says how to install Gamma Ray, described here. So I went there and says that the way to do it is to build it manually. There's a Gamma Ray project on GitHub. I'll go there. I'm cloning that Git repository where, I don't know, in today's directory. Git clone, Ctrl Shift V. Next, it says that I need Qt 5.5 or newer. Yes. CMake 3.1 or newer. Yes. A C++ compatible compiler. Yes. Gamma ray is built using so this is a grammar error. The normal CMake build process. So there's a file install.txt in the gamma ray source tree. Maybe there's information in the readme file. See installation notes. So it takes me there, install.md, not txt. So this web page is wrong. Installation notes. I need Qt 6, which I have, or Qt 5.5. CMake. KDSME, etc. Provide extra functionality. Let's run without extra functionality. So I should have CMake, Ninja, compiler, Qt, etc. in the path environment variable. Okay, let me understand what it tries to do. Okay, your system's installation of Qt will be used by default, which may not be the same. To specify the Qt version, you use CMake prefix path and point it to the folder of your installation. Install directory defaults to /usr/local, which is a problem. CMake install prefix. So CMake install prefix is one thing, and CMake prefix path is another thing. Okay, so let's prepare a command line. It probably expects me to create a build directory outside of the gamma ray. So this is the git clone of gamma ray. So f7 gamma ray minus build. Let's change there. Let's prepare a text file in here. And the content should be something like this thing. Let's comment it out for now. And then this thing. Path to gamma ray, so we go up one directory and then this thing. DC make install prefix where I want to install into the .local /bin directory, and I want this CMake prefix to be set. So CMake prefix path specifies where I've installed Qt, and CMake install prefix specifies where I want the files to be installed. So Ctrl+C, Ctrl+V, and then the directory where I git cloned gamma ray. So in the parent of this directory in S, and then in the subdirectory gamma ray. So this is correct. This is correct. This is correct. This is correct. And it generates Ninja files, which I do not have installed. So can't we make these be Unix make files? Unix makefiles is the default. Okay, and then the prefix, which is not this, but this thing. So copy, Control V. So it should start with home, Control C, then Qt, then the version, then GCC 64. Okay, Control S. So I should be in this directory and run this command line. I did not let's put Qt in the path. So this thing. Okay, then we're in the correct directory. Let's run cmake configure. So cmake prefix path, correct. Install prefix, correct. And then the gamma ray git clone directory. KF6 syntax highlighting is recommended, cannot be found. This is not okay, not a problem, because we do not have KD Frameworks version 6. It could not find optional packages Qt3D, yes, because I did not install those. Q6 QML compiler plus private, I'm not sure what this thing is because I keep hearing about it, but I keep not knowing where it is. I did install Qt6 Wayland Compositor in vehicle and infotainment, no KD6 libraries, and it could not find package config. That's a problem. So let's install some dependencies. Okay, so apt search. We want at least package config to be available. And there's nothing, no package config. Why not? Let's ask. Ubuntu packages search package config. Package minus config. Wow, being fancy. Lunar. Okay. Where is the source? Package conf. Wow. The list of files. Package minus config. What is this? Meta information about installed libraries. Yes, this thing, package config, C flags only I, libs only L, GNOME UI. From freedesktop.org. Owen Taylor. GNOME config, Miguel de Casa. GTK config. Okay, let's search for package config then. Package minus config is not installed because it's a transitional package. Where does it say that it's a transitional package? It depends on pkgconf. Which is what? USR bin package config. So again, name change package conf. Okay, out search, Control Shift V. Grep, Control Shift V. So there's a lib package conf dev and a package conf, and package conf is not installed, which is very strange. Control Shift V. It will install lib package conf and package conf bin. And I'll also install the... I'm not sure if I need the dev. Okay, so let's hope package config is okay. Then Wayland lib dev, something like Wayland dev, yes. Wayland so what it needs in here is a C library implementation of the Wayland protocol. This is optional just for Qt Wayland inspection. It found Qt 6. Many Qt 6 packages, xckb, OpenGL, Git. It already looks okay, even if we don't install whatever the Wayland package will turn out to be. Wayland library, lib Wayland. There's a ton of lib Waylands. Lib Wayland dev. Wayland bin. And dev, this thing probably. Let's install this one. Apt install, middle click paste. Yes. And let's run the configure cmake step again. So I'm okay with what it did not find. Let's see what it did. So mc, it created a makefile, so that's okay. F4. I want emacs4, enter. everything seems okay. Ctrl X C, F10, or we run make to build -J15. There's warnings. And it failed because why? Error 2. These are just warnings. Okay, maybe we need to use less CPU cores, so let's go with 6. Nope. Map view QML lint dir error 2. Error 255. But these are warnings, not errors. Yeah, I'll be back in a second. Okay, so I managed to compile gamma ray somehow, but the end result is not okay. So the last git commit in the gamma ray GitHub Git repository is from 1 month ago, and maybe it doesn't support Qt 6.5 yet. I'm not sure. So in order to build it, I need to clone the Git repository. I changed into that directory. Then I made in another place the gamma ray build directory. I needed to export the path. Then I needed this invocation of cmakeconfigure, which disables building docs. I had all sorts of other problems, like I need to disable QML lint. There was one private Qt header and symbol which has changed signature. Then I made and I installed into tilde/.local, which is part of my path environment variable on Debian derived operating systems. Then when running gamma ray, it gave this error: Yama security extension is blocking runtime attaching for GDB, which I need to enable by editing cctl.d/10-ptrace.conf and make sure that the value, the only pair key value there, has the value 0, not 1. Okay, so as an example, I start an application. Does not matter which one. And then doesn't matter if I start it from here. It seems to be injecting itself into the project, to the process main window. But it, for the GUI, for the gamma ray GUI, only shows the splash screen and nothing else. And gives this error. Gamma ray probe attach. So we'll survive without gamma ray, which is an important tool for introspecting and seeing what exactly the GUI application is doing, how many Qt GUI controls are there. What's the relationship parent-child? Inspect QML, layouts, Qt widgets, events, slots, signals, properties, and even edit some properties. Okay, so no gamma ray for us. Since I could not build gamma ray using the latest version of Qt that just released, Qt 6.5.0, and I saw that gamma ray, the Git repository on GitHub, does not have enough Git commits in the last 3 months in order to add support for the latest version of Qt, which among others has changed the signature of one internal private Qt header. So a method there used to take a size and now does not take any parameters. What I did was I went to the place where I installed Qt, which is ~/Qt. There is a maintenance tool executable, which again is an ELF, so native Linux executable. It's executable, so I double clicked on it and I changed the settings of the current installation of Qt. So I kept all of that was installed. I unchecked Qt 6.5.0. I don't need it anymore. And instead I selected the next newest Qt version that's not a preview, so it was released, which is Qt 6.4.3, which is this thing. Okay, and after that I managed to build gamma ray successfully. I am building gamma ray like this. So git clone the gamma ray GitHub repository. I'm creating a gamma ray build directory, but not inside of the git work directory, but one directory above. Then I'm setting these environment variables, 1, 2, 3, 4 environment variables. Then I'm issuing the cmake configure command line cmake prefix path where I installed Qt 6.4.3. cmake install prefix ~/.local, which means that my .local directory looks like this. So ~/.local is a directory structure similar to what's under /usr, or in the BSDs, the directory structure that's under /local /usr/local. So there's a bin directory and an include directory for .h files, a lib directory for so files, a share directory for manuals and images, etc. Desktop files. And .local ~/.local/bin is part of the environment variable path by default on Debian-based OSs if this directory exists. So if ~/.local/bin exists and you reboot your computer or you log out of your desktop GUI session and relog into KD Plasma Desktop, then the path environment variable will also contain the directory ~/.local/bin where gamma ray is installed. Okay, so I've started gamma ray and I've created using Qt Creator a hello world Qt widgets application, which means file new application Qt widgets application. I have double clicked on the binary, so it's called untitled 3 widgets, and it looks like this. It's an empty window. And then from gamma ray, I injected, so I connected the application gamma ray to the other process, which is this untitled 3 widgets process. And now I can do gamma ray things, so I can see how many Qt widgets exist there. There's just one of type main window, and its children are a status bar that's invisible at the bottom, then a menu bar that's collapsed or invisible or something somewhere, I don't know where, and the central widget which covers the rest of the graphical user interface. And this thing at the bottom right corner is a Q-size grip, and it has these dots. Okay, what else? We have timers running, information about my operating system and the packages that are installed here. So Kubuntu 2304, Lunar Lobster development branch, x86-64, Qt 6.4.3. The paths. We use the style fusion. These are how controls look like, complex controls, signals and signals as they are issued. So this is the main window, has the move, has received the changed int event. Okay, resources. These are all of the files that are embedded either inside of the executable or inside the libraries that, so the SO files that are loaded as part of the process. There's some for the QPDF. One for the Q message box, etc. Problems in this application? No problem. Two problems. Objects, so these are the Qt objects and their hierarchy of parent-child. Two network interface cards, one Q abstract model, I'm not sure what these are, meta types. These are all of the types that are Qt style and instantiated in this process, I'm guessing. Meta objects with their methods and enums. And properties. So QFont is a enum. QGradient is an enum. Okay, QObject has methods and properties. Messages. So these are log lines, debug log lines. Locales, fonts. Okay, so the application doesn't do much, and don't forget that it's really easy to kill gamma ray by clicking on the wrong button or tab. Okay, so next up, I want to see if I can inspect using gamma ray also an application of type QML. So I could inspect one Qt application of type Qt widgets, but what about applications of type QML? File, close all projects and editors. File, new project of type Qt quick application. Choose untitled 11. Untitled the current hour 16:31, like this. Next, next, just next everywhere. So it does have a main file or not? Yeah, it does. Where are you? So it does have a main.cpp file, so that means an executable will be created. Let's do that. So CMake configure was successful. We can build. Okay, so it finished building. We can run it. It looks normal. Let's put something inside the QML besides the title. What are our options? We can put a rectangle. Let's do that. Rectangle of a certain position, x 10, y 10, and size, height 100, width 100, and a certain color. Red. Ctrl S. Okay, let's run it to see how it looks like. Okay, and now we'll need to run this application without, I'm not sure if I can inject it when I run from Qt Creator, so let's try not to. So what we're looking for is where is the source code for this project, so it's this directory. And then the build artifacts are in a different place, which is in the parent directory, in the subdirectory build untitled 1631 desktop being the CMake build configuration. Okay, the application is named as a directory build untitled y631, which is up untitled 1631. Okay, and now let's try to use gamma ray on it. It asks me if I want to connect using Qt 6.4, so both the gamma ray and the application need to be built with the same major and minor version of Qt, so 6.4. And out of process, because there are two processes, gamma ray is one process and up untitled 1631 is a different process. And the PID, process ID of this application is up untitled 1631. The process ID PID is 31692. So let's connect to that. Okay, so it says in the injected application that it edits the title of the application. in the window title bar. So now it's the previous title, hello world, and then space and in parentheses injected by gamma ray. And maybe it edits even the icon. Let's see again. Yes, it also changes the icon of the application if the application does not really have an icon. So the application does not specify any icon. So probably gamma ray sees that thing and puts, instead of nothing, it puts the application icon for gamma ray after it injects. Okay, this thing. Okay, so let's see, apart from the fact that it changes the application icon and the application title, what does gamma ray do to this application? What can it do to this application? First of all, we're starting with widgets. It doesn't say anything, so there's 0 Qt widgets in this application, apparently. So one entry point is widgets if the application is Qt widgets. The other entry point is quick scenes if the application is Qt quick. So it is. So there's a Q quick root item, which is the top level, and the second one is a Qt quick / rectangle. Let's look a bit at the source code. So this is a window. What does it inherit from? It instantiates a Q quick window. And here it says Q quick root item. Okay, then there's the rectangle. Matrix is for transform node. Okay, so we can select one item that we want to inspect. Like this. Let's make the window a bit smaller. So there's this button which says pick element. Select an element for inspection by clicking on it. So let's click on select the picker element. I clicked on the rectangle and now the rectangle is selected in the object tree view. It's the same thing as clicking on the element in the object tree view. Then I can see additional information on the UI. How do we scroll here? Okay, so it says, really difficult to see, but it says that y is the distance between the parent top and this top, and is 10 pixels. And x is the distance between parent dot left and this dot left, and it's 10 pixels. Okay, we can see the property that Qt quick rectangle has a property named color, which has a notify signal, so it's observable, so it's a property that's observable. That means that if you read from that property, nothing extra happens. You probably just read from a member field. Whereas if you write to the color, then two actions will happen. One, you will set somewhere the color, probably in a member field, and then you will trigger an event which says the color of this one cute quick rectangle instance has changed and now it's red. And this event might trigger a chain of other events. For instance, if you have many children which are transparent, maybe a repainting will happen in all of the children such that they appear to be red although they are transparent. Okay, so by hovering on top of the properties, I can see that clip is also emits a notify signal, so it's also observable. Children rect has that thing. Children has bottom, does not. Border, no. Anchors, nope. Okay. What else? We know the name of a property, the value of a property, the type of a property. So this is actually a cute type, while as this is a cute quick type, so part of the module cute declarative. Okay, and it says where is this property implemented. So the color, as we know, is implemented in QML rectangle, whereas most of the other properties are implemented in the QML type item with an uppercase I. So in here we can see that the QML type item with an uppercase I is backed by a cute C++ class named QQuickItem. And the QML class rectangle is backed by the cute C++ class QQuickRectangle. We've seen in the documentation that rectangle has only the following properties. The others are just inherited from items. So first, anti-aliasing, this thing. Then border, this thing. Then color, this thing. We can see it in here, class QQuickRectangle. Gradient, we can see it in here. And radius, we can see it in here. Okay, in the documentation it appears that it's of type real, when in fact it's of type C++ double. Okay, so really powerful both inspectors, such that we can see an application as it's running, but we can also edit some of the things, or we can invoke some methods, some events from gamma ray. Okay, so the application is still running, yet from outside of this application, we told the application, hey, your rectangle is no longer red, it's now some sort of bluish color. How do I select blue? Okay. What else? So these are properties. So properties means a getter method and a setter method, and the cute property meta object runtime type information. Methods are functions of an object. So functions that have as the first argument the hidden parameter this, which is a pointer to the current object. Okay, as we saw, these are the methods that end in changed, are used for observable, to make a property observable. Height changed, enable changed. So we can see that in order to make GUI C++ classes make visible in QML GUI, you will need to implement some extra things, such as all of these changed methods and properties that actually have a observable characteristics. Okay. There's this data, which is from QQuick item. Sounds very interesting. What is it? It's a list of Q objects. The data property allows you to freely mix visual children and resources in an item. If you put a visual item in data, it will become a child. Any other type of C++ class will become a resource. So a timer is a resource and text and rectangle are children. Okay. We have methods, then we have connections, which means inbound and outbound. So there's the type QQuick rectangle is emitting enable changed when it becomes enable disabled. And there's also outbound connections. No bindings yet. QML context. There's inside of the resources a file named main.qml. Do we really have a resource? Let's see. Yes, we have it in here. So the entry point of the top level cmakelist.txt file is Qt add executable. So we can see that it creates just one executable named app untitled 1631. That executable uses just one C++ translation unit, which is the file main.cpp. Then there's the equivalent for generating shared libraries, which is, I don't know what the name, Qt add, library or something. There's this thing, Qt add QML module, which says that the list of QML files is main.qml. The URI is going to be untitled 1631. QML module. So this is the only thing that could create the QRC, the Qt resource compiler resource. So inside of this executable, there's a resource which is at the path QRC colon, so QRC being the protocol slash, and then in here we have the URI untitled 1631, which is the name of the executable. And then inside there's just one file main.qml, and we can see that this is a list qml underscore files. You might have more than one QML file here. This is for Mac OS. This is for Win32 Windows. It links, so the application needs Qt 6 Quick. So this is a specification for the linker. Find package Qt 6. The minimum version is Qt.4, and just the component Qt Quick is mandatory. But then probably the component Qt Quick depends on Qt Base and other Qt components. Language C++. Okay. So this part of the CMake lists file is used, or the entire file is used for creating a makefile file, which looks like, where are you? Oh, it actually uses Ninja. Okay, so it creates a configuration file similar to the makefile file. Makefile is for GNU Make, and it creates file for Ninja. Theoretically, Ninja is faster than GNU Make. Okay, so these are for the make install step, which copies to the destination, wherever that is. The executable. Just when you bundle it, okay. So we saw straight from gamma ray that there were resources, and what that resource was, a file. So the body of file main.qml is there. Okay, other QML contexts for the rectangle. There's an engine, QML application engine, which is created here. The context is valid. There's a parent. Not really. Oh, it's object, the null object. Two enums in the rectangle. Item accepts, item is, which are flags, and then transform origin. These are both inherited from QQuick item. So let's go there and search for flags. Nothing. Transform origin. So transform origin is an enumeration, an enum. So the possibilities are top left, top right, left, center right, bottom left, bottom right. And possibilities from 0 to 8. Okay, and then flags. Should also be an enum here. Okay, class info. QV4, so this is the special JavaScript engine that's not V8, which is the JavaScript engine from Google Chrome. And it's special for QML, QV4. Okay. Else QML type. Type name. Quick rectangle. QML type name. Quick slash rectangle. Oh. Element name. Rectangle. Version is creatable. Type index 607. So QML types. The type, not the object, has an index. Okay, what else? This is it. And then for QQuick root item, the QML type name is slash, no element name. So this is the type that has no name in QML, but in C++ it's named QQuick root item. Okay, and the index is 623. The type cannot be created in QML, only in C++. No bindings, connections. Methods and properties. Where is the title? Hello world. Because it does not have text. So it has a parent which is main underscore QML type of type QObject, which this one has an icon of type QIcon, which we can probably change. And then hopefully a text, title, something, title, this thing, which we can probably edit. Okay, so the title bar has been injected by me manually via gamma ray. Okay, what else? Qt quick rectangle, Qt quick palette. This is the Qt quick root item. Models, Q abstract model, MIME type. Events. Main underscore QML type. Child edit. Right now. 1 million of childs are added and deleted per second. I'm not sure what this thing is. System, signals, resources, scene graph, QQuick, QML dir, window, QML dir. We use the window. So the QML type window, and there's a QML dir for window, which is kind of like a QML library. QML application engine. The abstract item model, we saw it at models. QQuick rectangle, QQuick root item. Timers. There are many. Network. Nothing. And you can navigate from one place to the other using the right click. So you go right click, pick element. This thing. On it. Then you can go right click, showing quick scenes tool, which is this tab. Right click showing objects tool. It has an icon. I know how to go back. Code navigation, what is that? Back to where I was in quick scenes. Right click, showing meta objects tool in here. So there's one instance of the QQuick rectangle Qt style C++ object. Back to quick scenes. Right click, signals. We saw the signals that it receives. It's this signal. Okay. Quick scenes, right click, signals. That's the last one. You can invoke a method. You can copy and edit. So let's see, quick palette showing objects. Unfortunately, I don't know of a way to go back. Meta objects. and in signals. Okay, so you can richly see what's inside of a GUI application, and those things are live, are objects that exist at this moment that you can interact with, that you can push aside, that you can dare to invoke a method, that you can edit properties of. So the objects are alive and you can put your finger on them. Okay, let's use a binding. So let's say width is height times 2, Control S, build, run up untitled, run gamma ray, inject, and now we're going to bindings for this thing. And it doesn't show anything. So rectangle width is has a binding. I've sorted the list of properties, the list view, by the column property ascending. And it uses the wrong icon. It doesn't seem to know that it's dynamic. Let's change the height. Make this thing 200. And the width changed immediately. Let's make this thing 300. And the width keeps up. So width is totally not a fixed double, so it's not a literal, it's totally a binding. I don't see this binding, and I thought it's possible to see it. To somehow inspect it and see that the two properties, height and width, are also very different. One is a a special type for bindings for functional closures or something, and the other is an actual double value. So these are the values that are computed, the final values. The current values 300 and 600. So this probably gamma ray injects the application and tells the object QtQuick/rectangle or QtQuick rectangle or rectangle, depending on the programming language. Hey, what's your current width? And it says it's 600. Whereas I wanted a way for gamma ray to ask the rectangle, hey, is rectangle with a binding? And yes, okay, what is the right hand side of that binding? Okay, So that's about it for gamma ray. Let's stop it and carry on with our tutorial. So file, close all projects and editors. And we were inside the hello2 this thing, QML project. So Control Alt C to copy the full path of x minus expressions.qml project. File open, where are you? File open file or project. Control V, open. And now again back we have two files. We have, okay. So we have just two files. There's the QML project, the file with extension QML project, the file with the same name but the extension QML. The file QML project is going to stay unchanged for the next examples because you can't really, there's nothing you can edit here. And then the QML is the file that uses the QML programming language. It has in this example two Qt Quick C++ QML types, which one is item, the other is rectangle. They're instantiated both. This rectangle is the child of this item, which is its parent. And to demonstrate that with colon this dot height times 2 is actually not a plain old property setter being called once, but it's actually a binding. We can create a function and then assign to the property width the call of the function. So this is a function call, which if you call it once has a certain value. So it has height times 2 and writes this to standard output. But then the exterior of whatever, the entire right-hand side is actually captured and called as many times as needed whenever the object of type rectangle is told to compute its own width. Okay, so let's debug this thing. Okay, so this is called QML debugger. So it's in fact a QML JS debugger. It's a, you can see it in here, QML for QML runtime debugger. I'm not sure why this tool window is so small. Okay, so it's in fact a debugger for that special JavaScript engine that's inside of Qt Declarative that's not actually Google Chrome web browser's JavaScript engine v8. So it's, I don't know, what's the name of it? v4 QML something. Wiki QML. QML is the language, its JavaScript runtime is the custom v4 engine, for which we have an article, a blog article from 2013, which says that they started by using the v8 JavaScript engine for executing property bindings. and it says that each QML item, which is actually an object, had a inner representation specifically for the V8 JavaScript engine, once for the QML engine, and another one for the C++, just a Qt style C++ Q object. Each binding is represented as a JS function closure towards V8. Data type conversions from Qt to V8 and vice versa. Okay, so there was a ton of overhead not really needed in order to be able to accommodate the V8 JavaScript engine. It's really nice to accommodate the V8 JavaScript engine because that's really fast. But that's if you have just one or two bindings in your application, and those bindings call a ton of JavaScript source code, like millions of lines of code, which means that you're putting your business logic in JavaScript. Then yes, if you are going to switch between the Qt world and V8 rarely, but do a ton of computations inside of V8, then that's what you would want, to have the JavaScript engine be V8. But if you're actually having the business logic written in C++, and then almost everything is a C++ Qt style object, so the things that you expose from C++ and will be available in QML, all of the graphically visible QML Qt Quick objects and types, properties, and the bindings, and all of the Qt meta type information, such as properties, enums, signal slots, etc. All of the things are kind of in the same place in the Qt C++ style world. So then traversing between V8 and the Qt world millions of times per second is going to be slow if you don't have any complicated CPU intensive JavaScript source code. Then why would you keep changing context between the Qt C++ world and V8 JavaScript world? Okay, so they went with a change. The initial plan for QML was to have all of the business logic written in JavaScript. So yeah, then it made sense to use the V8 JavaScript engine. But then the direction changed, the course changed, and since many years, the preferred way of doing QML is to have all of the business logic written in QML in Qt style C++, and you only export what's needed from the Qt C++ world to the QML world, and then use QML exclusively for GUI output and input, so keyboard, mouse, touch, etc. Okay, so in this case, you want the cost when you switch from QML to the JavaScript engine to be minimal, even if the JavaScript engine is, I don't know, 2 times slower than V8, because you don't really have that many lines of JavaScript code. Those are extremely simple binding one-liners, such as this one. A binding, and it's just one line. This dot height times 2. the project with the codename V4VM. Started at Nokia in 2012, then migrated to Digia, a playground project, then integrated into the Qt declarative Qt module, fully compliant ECMAScript 5.1 JavaScript language engine, just-in-time compiler that supports Linux, Mac OS, and iOS. Does not use V8 at all. Could run in 2013 all of the Qt Quick demos. Very focused on QML use cases. So traversing between C++ and JavaScript is really fast, but pure JavaScript performance, so if you have a .js file with a million lines of source code, then it's probably not be as good as V8. Who knows? That was the reality in 2013. Maybe in 2023, the delta bit in performance between V8 and the JavaScript engine in QML is less. V4 branch. Okay. So this is what we see in here, a V4 debugger. So there's a debugger, there's a profiler, and in the QML file, wherever you have some JavaScript, such as the body of functions or maybe even the right-hand sides, you can place a breakpoint, and when you run the application, if you have QML debugging enabled, it will hit the breakpoint and pause there. This is an object, this is a function, nothing very interesting. F11, it cannot step into console.log, which is okay. What's the value of height? It's 300. So you would expect that height is 100 because that's what we want. We wanted this dot height, which is the rectangle height, times 2. So we want 100 times 2, 200. Whereas in fact, this height is 300, not 100. Why? Because this is similar to a method. It's inside of the scope of the item. So this is actually a method of this instance, not a static function, not a static method. So it actually has this on the first parameter, on the first argument, and it's a hidden one. Okay, so this dot height is 300. Okay, what about this? This is an object. Okay, what's its width? 400, so this one. What's its height? It's 300, which is this one. If we're going to give it an ID, and we restart. Then the ID should be somewhere. I cannot sort by value. I don't see it in here. Okay. What other property can I set? Clip is false. This is a very important property, which says that if a child exceeds the size of a parent, then that the parts of the child that are not on top of the parent will still be drawn. So that's clip false for the parent. If you set clip true for parents, then the children will not exceed their parents when drawing happens. Okay, so data, as it says, is the list of children and resources. So there is just one child with height 100, which is this one, and width 0. Again, these are the instant values. If I ask the rectangle, the instance of the type rectangle, so this object, what's your width? It will say 0 because nothing is assigned to it yet, just this closure. Okay. In application output Alt 3, we can see the console log, which is prepended by the string QML colon space. It says QML colon space, and then whatever was the parameter of console.log, which is the string hello world. Okay. Then it multiplies this, which is this height, which is 300 by 2, and it turns 600. Okay. So width of this, so this has height 100. What's its width? It's still 0 because the debugger has just exited line 1718, and now it returned back to the caller, which is line 11, and now the assignment will happen. Okay, and the JavaScript engine does not have, the JavaScript debugger does not have anything else it can break on. So the debugger is actually running, not post. And we can see 600 here. The function is called again. Why? Why is it called again? Well, because part of what it closes, so it closes this.height, which is this guy, might have changed when I resized the window. So this.height is still 300, and this computed is still 600. So each time I resize, even if I change just the width of the window, the binding is being called F5. And now whenever the binding is called, we will have text written to the standard output and the debugger will not break. Okay, so the JavaScript debugger allows you to pause inside pure JavaScript code, so such as line 16 where there's just JavaScript code, or in lines where there's a right-hand side that does JavaScript things, such as this right-hand side, which is a closure, which is a JavaScript closure, which is the value of a binding. Okay, continue running. And now it hates me because it says that there's a binding loop for property width. Which is at line 11, column 9. So this width is actually a binding loop. I don't know exactly why. I don't understand it, so let's continue. Again, so the problem is that the spirit is that we want the width of the rectangle to be double its height. So this does the correct thing because this represents this object. If not, we want this to be a method not of item but of rectangle. So we do Ctrl X and place it in here. Ctrl X, X. Ctrl S. And now let's see how it works. So rectangle height is 100 and width is 200. So it's actually 2 squares. This rectangle, yes. Okay. Okay. So what else? What next? We will look at the order. So we're working in a 2D plane. There's the coordinates that look like this. Just a second, let me install a image editor. Okay, file, new. This is a good template. Let's use the pencil, which is which. Thing. Type dot and size 4 is okay. Okay, so this is the monitor of your computer. This is the x-axis. This is the O origin of the 2D plane. And this is the y-axis. So OX and OY. OY goes from top to bottom, and OX goes from top left to top right. Okay, so this is 100 pixels, and this is 100 pixels. Okay, so Y grows from top to bottom, X grows from left to right. Okay. But there's a third dimension, which is called Z or Z order, which means that if you have two rectangles like this, rectangle 1 and rectangle 2, and if 2 has a bigger Z order, then you will see rectangle 2. And then rectangle Y, parts of the rectangle Y behind it. Whereas if the Z order Y is in Z order bigger than 2, then you will see 1, the entire rectangle 1, and just parts of the rectangle 2. So rectangle 1 will be brought to front, and the rectangle 2 will be brought to back, or buried underneath the rectangle 1. Okay. So for that we will revert the width, clean this thing, and we will have two rectangles. So objects by default, object instances by default in QML do not have a name. If you want to specify a name, you need to use the special property named ID. So we have a second rectangle that's not light blue but green, so that we can discern them by color. And then let's make the blue one a bit below the light blue one. So make this thing 120, and let's run this example. So the two rectangles are identical in width and height, in size, but we can see that just parts of the light blue first rectangle is visible. Let's make this even more clear. Let's make this thing, I know, 90. Okay. And what you want to change in order to make the rectangle light blue be on top is to improve its Z order. So Y is always, if we run this application 10 times, the rectangle green is always visible entirely, and the light blue one is just partly visible, is because that QML visible objects that are created first are going to be buried underneath the GUI QML objects that are created later. So later means more visible in the Z order. Okay. So for that, let's look at the property X. So the property X is this one, X of type double, and it's on the QML type named item. And in the same place, there's a parameter with the name there's a property with a name Z. Okay, let's go F1 on this thing. Okay, Z plus 3 like this. So let's read the documentation. Says Z is a double. Decimal point real QML value type. So it's a double precision type, a value type provided by the QML language. QML value types. Single value int. Value that contains properties and methods. Generic type var. Okay. Bool. True or false value. Reals stored in double precision. Floating point and the same as real, yes. Okay, and string is stored as qstring. We saw it in when we inspect it using gamma ray. So it passes from QML to C++, it's converted from qstring in C++ to string in QML. Similar to the JavaScript string type with an additional property called arg for doing positional substitution. Okay. Back. URL, which is probably QURL. Okay. Variant, a Q variant. Var type. A regular JavaScript variable. Can store numbers, strings, objects, arrays, and functions. Okay. Date. QDate or QDateTime? Avoid use for annotating JavaScript functions that return the type undefined. Okay, just for that. A list is a QML list property. We also saw this thing in the gamma ray when inspecting the QML type item, because it had a list as a property member, which is for data, this thing. This list of Qt object in C++ was actually a QML list property of QObject. So there's value types and QML value types, QML object types. Size. Okay, so there's two types of QML value types, which are built into the QML programming language and which are provided by QML modules, such as color and size, and we have seen both. Okay, so let's run this example. Now the rectangle that's light blue is on top of the green one because I know maybe they both had z order 0, but since the second rectangle was created after the first one, then the second one was most visible than the first one, so the green one was most visible. So you can either increase the z order of the first rectangle, or you can go reverse and decrease the z order of the second element. It's the same thing. And let's inspect and see exactly what is the default z order. Again, I guess it's 0. So we can't really inspect these things, right? Qt Creator Process Launcher. This thing QML. Okay, so it's actually using the executable QML, which is the same as the executable QML scene, which comes with the Qt framework. And then it just starts the correct x minus expressions.qml file. So this, I guess, we can inject gamma ray into. Okay. So it keeps the original icon, but it enhances it with parts of the gamma ray app icon. We want to see what are the values of the z property of these two elements. So because it's a QML application, we go to Quick Scenes. We select the green one. So picker green. We can see the actual rectangle, how it's hidden by the light blue one. And we go at the property z, and it's -1. whereas the first rectangle has the z order 0. So by default, all of the properties named z have the value 0, and by increasing them with 1, you can bring that element to the front, because all of the other elements have the order 0. The single element that the single QML control, GUI visible control that has z greater than 0 will be brought to forward, brought to front. Okay, I'm not sure why bindings do not work. Let's close this thing. Okay, what's next? So the hint when you click on rectangle says F1 key on your keyboard. So I press that one. We can press F1 again to maximize the help window. So it says the rectangle QML type inherits from item, which has many properties, whereas the rectangle QML type has just some properties. And Z is not one of the properties of the type rectangle, whereas the QML type item does have a Z property. And the documentation in Qt is really good when it works. Concise, to the point, really good. Okay, so the documentation says all that I said. So the default stacking order for the Z order is 0. Items with the same stacking value are drawn bottom up in the order they appear. Negative stacking value are drawn under. There's an example with Z1. Children above parents. So this is a children, this is a parent, and this is a parent. So blue was added last, so it's on top of the parent because items with a negative stacking value are drawn under the parent's content. So children usually are drawn on top of the parent's content, but because red encloses blue. Where are you? In here. So you would expect that blue is visible, that red is behind it, visible just partially, and you would expect that all of this part is white. But that's not true because parents don't do clipping by default in QML. So they allow their children to exit outside of the parent. So it exits the red rectangle, the blue rectangle. Okay, and then the children is put with z order -1 to appear below all of the items at the same stacking level at level 0. Okay. What about X and Y? Where are those? They're real, and they define an item's position with the default 0, and it's actually pixels, and I'm not sure why it doesn't say that thing. Okay. Implicit size for most items is 0 pixels by 0 pixels. There's the difference between width and height, width height, and implicit width, implicit height. Okay, so these size X and Y's are actually pixels, and these are relative to the parent. So if we put one rectangle inside of the other, and they both start at 100 by 50, they will be at, this rectangle will be at a different X and Y position compared to the item, and this rectangle will be at different X and Y position compared to the item, because the X and Y is relative to the parent. So it says that this instance of rectangle is at position 100, 50 inside of this container, and then this container is at position 100, 50 in this container. So let's run it. Okay, so these stores somehow are displayed somewhat in a diagonal. Okay, and the fact that the green exits the parent is because of the clipping. Clip is false by default, and we need to make it true. Okay, and this is it. What is this? Just a second. Let's look at the clip. Whether clipping is enabled, the default value is false. If clipping is enabled, an item will clip its own painting. Yeah, because of the Z order. Okay, so outside of the light blue rectangle, there's 0 pixels of the green rectangle. And if you use this source code for the QML file, then you have the first rectangle and then the second rectangle, and the second one is visible because they have, both rectangles have the same Z order, which is 0, and the one that's created later is visible. Okay, so the green one is visible, but if you move the Z order to the back, then this rectangle will not be visible at all. Control S and run. Okay. Let's see about the visibility. This thing. So this guy says item is visible but partially out of view. And it has this exclamation mark warning icon. Number of children is 1 for the light blue rectangle, and number of children is 0 for the green rectangle. Okay, this has clip true, this has clip false, which is the default. Visible, still visible, but practically invisible. Legally visible, but in fact not. There's no pixel that's actually visible by the user. Okay. So again, the X and Y are pixels. They are laid out like this, OY and OX, and they're relative to the parent. So this X and Y is relative to this parent, and this X and Y is relative to this parent. Okay. Escape to close the help. Okay, so we've seen that this is this, the current object, this is this, the current object. Okay, even if it's written like this height property is of this object, current object, not from the parent object. So if we define height and then we go height times 2, then this does not refer to the height that we just defined. No, it refers to the height that will be defined on line 9. Similar to what would happen in C++ if you say this dot height. It would not look at the parent. Okay. Let's go to the next example. So import Qt Quick 2 item 300 by 115. We have a text and a rectangle. So text, we give it an ID, text element X and Y, 50 and Y 25, text property, Qt Quick, and then there's a what is this? Font dot family Helvetica. Font dot pixel size 50. Control S, rectangle X 50, Y 75, height 5, width text element dot width, and color green. Okay, let's see how it looks like. Qt Quick. So it does not matter what text we have, does not matter what string it's in here. The size of the text QML item, the width, will be given by font config, harf bus, etc. Depending on the text, its font pixel size, its font family, so it's the actual width that's necessary in order to display all of the text correctly. That's the actual width of the QML item of type text and ID text element. And then that actual computed width of text element is going to be used. We compute its width. This is the closure, this is a binding, and this is the property of this object. Okay. Always save files before build, yes. Okay, so this makes that the rectangle that's green, 5 pixels in size, and starts 50 pixels. So the top left corner is at 50 pixels below the top left corner of text element and is green. Both the rectangle and the text widths have the exact same width. Okay. There used to be a tooltip when you hover on top of green where it shows the color green and also a color picker. I'm not sure why I don't see this hover on top of the green color. Okay. And then what it changes, what happens if we keep the rectangle, we keep the text, we just change the type of control of this control. Text is similar to a label in Delphi, so it's text that cannot be edited by the user, whereas similar to a text box, so text entry control is a text input. Let's go F1 on it. So inherits from item, displays a single line of text that can be edited. Is used to accept a line of text input. So similar to a single line text box. Okay, let's run. So this is where we can see the bindings in action, because the first item inside the item is of type text input. So this allows us at runtime to actually change the text. And we can see that as we delete a character, the rectangle width changes. Okay. So even if the control is editable by the user, the QML control is editable by the user, the width will be computed from time to time as the observable events are triggered, and that will trigger this observable event text input text element dot width, which will trigger recomputing this closure and will trigger assignment to the width actual value of the width property. Okay, so the width property has two things, has a binding and an actual instantaneous value. If you ask the rectangle what's your width, it will say, I know, 300. But if you tell the rectangle, hey, is width a binding, it will say yes. And if you ask it what's the right hand side of the binding, it will say text element dot width. Maybe not exposed via C++ runtime type information, via Qt meta object, but it's still in there somewhere inside the QML engine. Okay. We probably can put a breakpoint here and debug. Okay, so text dot width, let's put this thing in here. Text element dot width is 0 because it wasn't rendered yet. Then is 318. Then so computing rectangle width is not performed if there's no event that tells us to recompute the right hand side of width. So it's not based on a timer, it's based on events. It's not doing polling, it's actually event based. Only when needed, the right hand side of width is actually computed. Okay, like this. Now it's 290. And the debugger tells us in the application output that QML rectangle has a binding loop for the property width. Okay, so we talked about children, how they are being painted. The last one will have more of its pixels painted on the screen. That depends on the order. There's a clip property that by default is false, which allows children of a parent to have their pixels drawn outside of the rectangle of their parent. Can items overlap? Can children be displayed outside of their parent? Yes. the coordinates x and y are relative to the parent. Colors can be represented in two ways. You can use the properties. So let's stop the debugger. Escape. So F1. What was that? Cute color. So it's an RGB, A meaning transparency, RGB meaning red, green, blue, with 255 for each, so 1 byte. What am I saying? Why 1 byte is 8 bits, so 2 at the power. Yeah, that's AA is a 1255, RR is 1255, GG is 1255, and BB is another 255. So let's use this notation. So we want a ton of red and not that much of the other colors, and semi-transparent. So let's make that half transparent. So hexadecimal characters are, the digits are from 0 to F. That means 16 possibilities. The middle would be 8, so let's go 8, that's the medium transparency. And then very much red. So let's go with EE. And a few of the others. So let's go 22, 55. Control S. And let's see how it looks like. Okay. So it's transparent. You can see the uppercase Q letter, even if it has a rectangle drawn on top. Let's make the height bigger. Control S. And the X should be 40. This and this should be 20. Not the X, but the Y. So the Y should be 60. Because the Y goes from the top to the bottom. And this should be back to 50, such that they start at the same spot. Okay, so we can definitely see that there's a reddish rectangle on top of the text, but still the text can be seen from beneath it, because the transparency of the rectangle is half-half. So 50% transparency. And then EE is almost FF. FF means maximum red, and EE is not that red. And then 2 and 5 means green 2 and blue 5, which makes it a bit, you know, magenta-ish. Okay, let's make it maximum red, no green, and maximum blue. What's this color? So maximum red and maximum blue. That's violet or something. Control S and run it. Purple. I know. What's the name of this color? We can increase transparency by increasing the value in these bytes. This is just 1 byte. Okay, make it almost maximum transparency. That's BD. Almost maximum non-transparent. Okay, so now we can barely see the text behind the rectangle. Okay, other than that, we have SVG color names such as red, green, and light steel blue. These are the SVG colors with their value with just 3 bytes. Let me a bit compute what a byte is. So a byte is 8 bits. Okay, so that's 2 at the power of 0, 2 at the power of 1, that's 2, that's 4, 8, and 8 plus the rest, which is 7, that's 15, that's F. So this part is an F, and this is also an F. So 1 byte equals 8 bits equals 111.111 equals FF. So this is in 2 hexadecimal digits. This is in 8 binary digits. And 255 in base 10. Okay, so you can omit the alpha if you want. So let's do that. Remove the first byte, the first 2 hexadecimal digits. And run. Okay, so now it's not transparent anymore. There are functions that we can use: qt.rgba, q.shsvas, chsla, darker, lighter, tint. Whoa, what does this thing do? Let's put a breakpoint in here to see if it's a binding or not. And it's not a binding. How is that possible? How does it know that it's not a binding? How do we convert a integer to a color? Like this. So qt.rgba, and this is text element.width, which is a float, a double, which is a real, which is a valid parameter for the red channel. and the rest will be 0. Control S, run. RGBA width. So now RGBA width is 0, which means it should be all zeros, which means it should be black. Let me inspect this thing because it's interesting. Control S. So it's totally binding. Text element width is 0, okay. It's 318, which is black. Exactly. If I delete something, now it's 290. It's still black. 262. Two to 6. 187. 'm not sure what's wrong there. It should have worked. Red, green, blue, alpha. So this is a binding. Any function call is a key binding. Is a data binding. Okay, so GB, RGB. Not transparent at all. This is a total mystery. Red, green, blue, alpha. white and not alpha at all. So where's the alpha channel? So the last parameter is alpha, and you want this to be as big as possible, to not have alpha. All components should be in the range 0, 1. Okay, so red, green, blue should be in the range 0, 1. Okay, now you're talking. 0 dot 0 dot 0 dot. The last one is alpha, as it says in there. Okay. So I'll do it text element dot width divided by what? By 300. Control S. Still does. Oh. Okay, now you're talking. And then it stops when it plateaus at 300. So let's make this even bigger at 700. Okay, so as the text input becomes wider, the color of the rectangle becomes redder. And again, it plateaus at the width 700 pixels. Okay, interesting. What else is there? Okay, X and Y can be negative. It's negative because it could start outside of the parent, and there will be no problem because there's no clipping. Let's see if we can have a rectangle inside of text input. Yeah, we can have such a thing, but then it doesn't make any sense to have an X and a Y. Okay, and we can even have it outside of the rectangle of the text input. So we can have Y colon minus 30. And if we go clip, pause, then the rectangle will not be visible anymore. Clip false is default. Default is false, so make it true. And now it's not visible anymore. And if we inspect it using gamma ray, it will complain. With this exclamation point icon, saying that is visible but out of view. Okay. Next. Okay, so let's do images now. So we have a rectangle. Where is it, this thing? Rectangle width 400, height 400, color something blue, RGB. And the child is an image. Okay, X and Y. Y 150. And it has just one thing, a source. Okay, let's draw a rocket. File, new, 150 by 150. Make it transparent. Okay, and let's create the most beautiful rocket ever. Black one. Okay, so this thing. Some flames. Whoa. How do we write some Russian things on top of the rocket? In the circle. Like this. Great. File export as the today's directory, this thing. Right click, copy, Control V, slash, and the name is rocket. Export rocket. Great. Great rocket. Follow symbol under cursor. Interesting. So you cannot follow symbol under cursor for a property, neither a type, but you can for a rocket. Because that's actually a file. Okay. So it says that we have two QML controls, one of type rectangle, unnamed, no ID, and the second one of type image, unnamed. The first one will be presented as a X11 window, which we know its size 400 by 400, and the image does not specify a size, just specifies that it starts at 150 by 150. So the height and width is actually taken from the size of the rocket.png file. So that has 150 pixels. The PNG is 150 pixels by 160 pixels, so it's a square image. If we specify a size for the QML image control, then the rocket will be stretched. So let's see how that is. Width 500 by 500. Okay, so the image continues to start at coordinates in here 150 by 150 in here, but it's stretched such that it covers 500 pixels by 500 pixels. And since the rectangle is represented as a X11 server window, by resizing the window, you actually resize the rectangle, which is a top level item. Okay. That means that the QML engine knows about the actual size of the PNG file. Okay, let's look at the properties that separate image from item. And an interesting property there is source size of type size. So a QML size is a QML value type that's where is it? So it's QSize or QSize F, where QSize F is a URL width and height. So it's a tuple of two floats, doubles or whatever they are. And QSize is a tuple of width and height. Integer point precision. Okay. And QML value types, there's two types. There's ones that are provided by the QML engine, the QML language, and ones provided by QML modules. And the QML Qt Quick module provides the QML value type size, which is a pair of width and height attributes, might be two doubles, might be two ints. We can specify it as the string 150x50, so as a string with an x inside, as Qt.size 150 by 50. We can use it for bindings. There's the image source type, so image.source_size.height, image.source_size.width. Let's go back there. So this thing source size, width and height. We can ask the image, what's your size? Okay. So we can, for instance, make the image be twice the actual size of the PNG. So we use a binding, Ctrl+C times 2. Source height times 2. And if we put a breakpoint in here, we'll see if it's a binding or not, and it totally is. Yep, it is a binding. It starts by being 0, of course. Then its actual value, so 150 by 150, as read by the PNG image format decoder, which is a Qt plugin. Okay. What's next? If the image is huge, like 1 GB in size, then the image will take some time to download. The download will be asynchronous, and there's an event that's called component.onCompleted. That tells us when this QML object has finished rendering. So let's implement that. Component dot on completed. What to do? Console.log. Okay. So console.log for log for console for console.log. No documentation available. Okay. So it accepts any number of parameters. W3 schools, yes, you're really good. Could have a just one parameter of type string. Message required. You can write any object, array, a list of objects, a string, and this with substitution, objects with which to replace substitution strings with MSG. Additional control over the format of the output. So the first parameter is really important. If it's a string, then the next parameters will be interpreted as substitution arguments. Otherwise, they will be interpreted like this. So if you have console.log with many parameters, the first the type of the first parameter is really important. Deep clone. Okay. So we'll print with height. And source size. Like this. So this is a struct, a QSize, yes. So it's a built-in value type in this. No, it's a part of the QtQuick module. So it's kind of like a C++ struct. Whereas these two are doubles. So let's run it. It says QML 300 space 300 space QSize, so the type, and then 150 and 150. The size of the PNG is 100 pixels, 150 pixels by 150 pixels, and the width and height of the image is twice the size of the PNGs, so it's 300 by 300. Okay. So this is the syntax for event and then event implementation. So the right-hand side, which is actually the body of a JavaScript function. Okay, let's see how What's the documentation of uncompleted nothing? Encapsulates a QML component definition. Instantiates QML component. Components are reusable encapsulated QML types with a well-defined interface. Are often defined in component files, QML files. You can define QML components inside of another QML document, not the QML document of that QML component. Small component within a QML file. Okay. And then it gives the example of a image that's really large, and image has an event named on status changed, and when the while it's loading on status changed is called, and console.log writes the source size just twice. And there's a property image.progress which goes from 0 to 1. It's a double, and it's 1 when it finished loading and 0 when it started loading the image. Okay, let's look at that. So image f1 and progress. Real read-only starts from 0, not loaded, and ends at 1 when the entire image has finished loading. Okay, so we can use this property to read from it and then to display, for instance, a progress bar. So the progress bar might be a rectangle that has the width 1000 times this image dot progress. Okay. Then there's how to use an image to create, for instance, the window decoration of a window. For that we use we take the border images, so the left border, right border, top border, bottom border of the window, and the corners, the four corners from an image. The corners will not be scaled, and the horizontal borders are scaled, the vertical borders are scaled. The middle region is scaled. And there's types of stretching, stretch, repeat, around. Okay, so let's look at an example. Okay, let's do that. How we do that? File, new, 1, 2, 3, 4. Make this 400 by 400. Make this transparent. Okay, and we'll need a grid. I know how to do that. I don't know how to do that. Just a second, let me search. Okay, so I searched on the internet GIMP grid, and it tells me that the grid exists by default. It's just that it's hidden. So you toggle it with by going into the GIMP main menu, view show grid. So view show grid. And then the grid was too small. So I've edited the grid. So image and configure grid. I made it 100 by 100. Okay. So let's recap. We have 400 pixels by 400 pixels, and then squares of 100 pixels by 100 pixels. So 400, 100. So we need a to create an image that looks like this. Starts at this position. Inside here and goes to here, and then from here goes to here, and then that's it. Hopefully we closed this thing. Control C. Let's use the bucket. Let's fill. Not enough. Okay, so we need to edit a bit. Okay, and like this. Now we put a bucket there. Oh, kind of ugly bucket. Let's find a better color. Okay, and this pixel I do not like, so I need to delete it. Where is the eraser? This guy. Oh. Delete. Okay, like this. Okay, zoom back. Okay, so what we did, we have an image that has 16 equal squares. These two squares are going to be used as the right border, these two as the left border, these two as the top border, transparency as the bottom border. And then the corners will be used as they are without any scaling. Okay, so let's see if this is what really happens. So wind decoration, window decoration. Okay. So let's try that. So we have just a border image, nothing else. Let's also have the rocket inside. Okay, not this. Width and height. $300, $400. Let's make this 500 by 500. And source, colon, and then Control V. Let's see how it looks like. Interesting. Next, border. And this is an object. So left 100. Top 100. Right 100. Bottom 100. Okay. And the tilings. Horizontal tile mode stretch. Okay, auto completion works. And vertical tile mode. Okay, stretch. Control S and go. Okay. So as you see, the corner remains unchanged. This is like a speech bubble, so the speech bubble will increase in size, but this bottom left triangle will stay the same size. It doesn't do what we would like because the image is not anchored. Let's try to do that. Okay, so we did not see anchors yet, center in yet, and parent yet, but still this is a sneak preview. If we keep increasing the size of the window, the rocket will stay in the center of the window, which is exactly what we want. But if we shrink the window, then the rocket will exit and touch this thing which we want to be a window border, So it touched the window, the bottom window border. Okay. Next, it supports GIFs, but for that we need to use animated image. So animated image, and then width and height, and source, and let's get a GIF. Imp Wilbur. Nothing, nobody has animated Wilbur. Whoa, that's a loading. Save image as, and then in here. Okay, loading. Yay. This is centered in it's itself, so it's centered. Interesting. What if we inspect this thing? So there's a cute, quick animated image at frames. How many frames? They keep increasing. No, so it goes from 0 to 300. It's 360 frames. Okay, interesting. Qt quick animated image, Q movie, Q quick palette. Q quick animated image, Q quick slash animated image, animated image. Okay. Enough inspecting. what else is there? Yep, there's that rectangle. Okay, width 350 and not width. Height 50. Color red. No width. Okay, width 350. Okay, and the width will actually be according to the current frame. So we need an ID, animated image, Control C, Control V, dot, something with frame, frame count, image dot current frame. Divided, current frame is hopefully not an integer, it is. To cast this thing to, I don't know, double. How do we cast in JavaScript? Real. This. And this times AI dot width. Real is not defined. How do we do not integer division in no. Yay. I'm back from the start. Frames. Great programming. Next. There's an on status changed. Only when it finishes loading will look at the frames and frame count. Rectangle x parent width minus width times animation current frame. So it creates a rectangle that actually moves, not a rectangle that increases its width. So something like this. But it has no width, so should have a width of 20. So it's this thing. Okay, enough. Okay, then we have transformations. So a QML object continues to occupy the same rectangle, but we can apply 3 transformations to it: opacity, scaling, and rotation. So opacity means it becomes more and more opaque, transparent, from 0 transparent to 1 opaque. Scaling means it increases or decreases its size by doing a multiplication. And rotation rotates clockwise in degrees. Okay, so let's do opacity. What do we do that? We can do opacity like this. So goes through x to y to from 0 to 1. So this thing goes from 0 to 1. If it does float division, if it does integer division, then no, it does not. Yeah, it does float division. Okay, so done. We did opacity transformation. Okay, then we can do scaling. So we scale just a rectangle. This should start from 1 and go from there on. So make this times 200. Too big. Times 50. Why is this so big? Why is 1 times 50 5 million? This? I'm not sure what happens here. Well, because height and width are 20 and 50. So times 10, that's 500, way too much. So we need to multiply this thing by, I don't know, to make it as at maximum 200. So that's 4. And it seems to go outside of the window. Why is that? Yeah. Because the x increases linearly, 1, 2, 3, 4, 5. And the rectangle itself continues to start at y0, so it's what's the y of the rectangle? Without the scale, it should have y0. Okay, so this is the actual rectangle. These are the x and y and width and height, what we see here. But then scaling will shrink this below 1. So if it's below 1, it will shrink it. If it's above 1, it will increase it. That's why at the start, the rectangle doesn't touch the title bar of the window, because it's scaled less than 1. So it's 0, something, which means it is displayed, the pixels of the rectangle are displayed in a smaller rectangle than the actual rectangle of the QML control, the QML object. So the 3 transformations are just for where to put pixels on the screen, just for the eye of the user, is not the changing in any way the x, y, height and width of the QML object. So rotation is actually given in 360. So in degrees, not in radians. And they go clockwise. So 330 is almost back. So 360 is the same as 0. And rotation is 0 by default. Okay. And let's prove that. So here we can prove that the image, which is a rectangle, so the QML object named image with the ID image occupies this rectangle with the coordinates x50, y50, and width and height, the source width, which is 150 by 150. But then if we apply the transformation rotation, 45 degrees, so the rocket is now like this on the diagonal of the containing rectangle. But then we can say don't use as transform origin the center of the PNG. Use as transform origin the top left of the rectangle of the image. So now the PNG is shown in here. It's transparent. Okay, so it's shown like this. And it exits the rectangle of the image, it exits the rectangle parent, and it also exits the window, the X11 window. Okay, because there's no clipping. But then again, the image is still here, the rocket is still here, it's just that the pixels are displayed here.